Good morning, everyone, and welcome to training. My name is Julie Sievers, and I would like to welcome you. So a couple housekeeping issues before we start. So if you have more than one person at your site, please send us an email and tell us who all is present. We are taking attendance based on how you signed into Skype. So if you signed in with your phone number, or I know there's at least one anonymous caller, also please send us an email and tell us that you're there. We need to match phone numbers to people so you can get your CU credits. As we go through today, the training, if you have any questions, there is a chat box available, and please put your questions into the chat box, and we will respond to those as we go. The presentations today are being taped, and they will be available on the ISG YouTube channel. You will get a confirmation email by the end of the week with your CUs and a link to the recording and a survey. So if you would like to see additional or other topics covered in the future, please be sure to tell us that in your response to the survey. So we're going to start today with current topics. There we go. So we're going to start by talking about the COVID-19. So as you all know, you are considered essential workers, and first and foremost, we want to thank you for all your work and all that you're doing. We know that this is a trying time for everyone, so thank you for all your work. So a little bit about the risk. According to the World Health Organization, there is no evidence to date that the virus has been transmitted via sewer systems with or without treatment. According to EPA, the COVID-19 is a type of virus that's particularly susceptible to disinfection. So standard treatment and disinfection practices are expected to be effective. According to CDC, the virus has been found in untreated wastewater, and if you're following the current news, there are some studies underway to determine if they can determine the extent of a community's infection based on the amount of virus they're finding or antibodies that they're finding in the wastewater system. So some really interesting research being done on that, so stay tuned for more. But there is no information to date that anyone has become sick with the virus because of exposure to wastewater. What that does mean, though, is you need to follow your standard practices for protection. You need to follow your PPE requirements. You need to practice good hygiene, good safe work practices, and as always, make sure that you're washing your hands well. So there are several resources available out there, and EPA has a good resource for drinking and wastewater. And it covers system operations, laboratory capacity, funding and financing options. It includes a pandemic incident action checklist that I'll talk a little bit more about, and other resources. So if you're having trouble or challenges with system operations, I would encourage you first to reach out to the state DNR staff. Reach out to your field office for operator assistance and to your the operator certification staff. If you are not a member of WARN, the Water and Wastewater Agency Response Network, I would encourage you to check that out. There is no cost to join. In Iowa, it's called the Iowa WARN, and it's a program that you can use for mutual aid, for equipment, for operations, and it spells out all of the requirements for that. It is not very onerous to join, and it's I would encourage you all to check that out and do that. And then there are circuit rider and technical assistance programs out there, and they're going to vary by state, but in Iowa, it's Iowa Rural Water, IAMU, others, And I would always tell you to reach out to your engineers and consultants if you have issues or questions as well. So sampling. So these are Iowa-specific guidelines. So if you are listening in from another state, I would encourage you to check with your state regulatory staff. But in Iowa, you need to sample according to your NPDES permit. And that includes at the frequencies and locations required. If you're having problems doing that due to interruptions or problems for access, contact your DNR field office. There is some flexibility available in meeting your permit conditions, but you need to consult with your DNR field office staff in regards to those and in regards to other options that you have. So a little bit about the Pandemic Incident Action Checklist. This is a checklist resource from EPA, and it addresses impacts to both drinking and wastewater utilities. And the following are included, but there are additionals. So staff shortages due to absenteeism or illness, supply chain disruptions, if you're having trouble getting chemicals or materials or personal protection equipment, and then interruptions in field operations. If you're having challenges making repairs due to lack of materials or staff, meter reading or sampling, and then simply the inability to maintain all operations. The checklist is divided into 3 sections, and they call them rip and run sections, plus a contact list. So it's divided into actions to prepare, actions to respond, actions to recover, and then the contact and resources list. I'd encourage you to look this up. It's available on both EPA's Water Utility Resources for COVID-19 website and the DNR website. And I would encourage you, particularly as we are taking actions to respond and recover, that you look through this, consider the actions and the information that's included in it. So some additional resources. So as I mentioned earlier, the EPA has a COVID-19 water website. It includes both drinking water and wastewater. The Water Information Sharing and Analysis Center, Water ISAC, has good information. The Centers for Disease Control and Prevention, CDC, has a page specifically about water transmission and COVID-19. The Iowa Department of Public Health and the World Health Organization also both have very extensive COVID-19 websites. So switching gears, a little bit about PFAS. So these are per- and polyfluoroalkyl substances, generally pronounced PFAS. This is a big group of compounds. It includes more than 500 different compounds, and they're found everywhere. They're starting to be called forever chemicals. These are all man-made chemicals. None of them are natural or found normally in the environment. They have been manufactured and used since the 1940s, and PFOS, pronounced PFOS, and PFOA are the 2 that are most studied and the 2 that you hear the most about. So where were these used? They're used in a number of applications and a number of uses. So the one that you hear a lot about is AFFF, which is firefighting foam, particularly used at air bases and airports and air fire training centers. Stain and water repellent coatings for textiles. So think about things like boots, raincoats, the stain proofing on or stain resistant coating on furniture and carpets, and other uses similar to that. It's also the oil and moisture resistant food packaging. So think about the coating on pizza boxes, microwave popcorn bags, and fast food wrappers. It's found in a number of household products. It's the Teflon or the nonstick coatings on pans. They're found in paints, waxes, and cleaning products. They're also found in personal care products, shampoos, dental flosses, cosmetics, those types of things. They're used in metal plating and etching, in wire coating and insulation, and a number of other products. So why are these a problem and why do we talk about them? Well, they bioaccumulate, which means they don't degrade and they persist in the environment. They don't degrade under natural conditions. They dissolve in water and move with groundwater precipitation. To degrade them, they will do that thermally, but it's at very high temperatures, greater than 900 degrees C, so centigrade. And there are numerous health issues at very low levels, parts per trillion, and the health effects include low infant birth weights, effects on the immune system, some cancers, increased cholesterol levels, thyroid hormone disruption in humans, and a number of other that are under study. So EPA has issued a drinking water health advisory for two of them and the combination. So PFOS and PFOA and the combination of the two at 70 parts per trillion. EPA has also issued a preliminary determination to regulate these in drinking water. So PPT is parts per trillion or nanograms per liter. So that's 1 part in a trillion parts. So examples of how small these levels are, it's about 30 seconds out of a million years, or 1 drop of water in a football-sized pool with a depth of 43 feet, or it's 1 inch in 16 million miles. So these are very, very small levels we're talking about. So in wastewater, we see PFAS found in domestic wastewater coming into your influent, in industrial wastewater, in landfill leachate, and in water treatment plant waste if your water treatment plant is removing or doing treatment to remove PFAS. We're also finding it in your effluent and in biosolids, and it's present in both. So this is a cycle that I want to just spend a little bit of time talking about. So truly what we're doing is we're just moving them from one area to another. So remember, PFAS don't degrade, they don't disintegrate, they don't come apart. They persist in the environment. So if you have PFAS in an industrial use, whether it's a production or a use, if you're getting wastewater from that industry, it can be in your influent and go to the wastewater treatment plant. If you're getting landfill leachate, it can come to you through that, or it can come to you through residential wastewater, domestic wastewater. It's found in products such as food waste. It's found in packaging and in materials that are treated, and we see that come to the wastewater plant that way. Generally, it will pass through your wastewater treatment plant, and it can be found in your discharge, in your effluent. It's also found in your biosolids. And one of the challenges then is during biosolids, after you've land applied, it can infiltrate into the groundwater. It can run off with surface water. It's also taken up in plant intake. And we'll see that then translate to food products and back into the cycle. So a number of ways that it circulates. And the other way is if it's in your drinking water source, generally it will pass through the treatment process and end up in your effluent, in your influent through your drinking water, through your source water. So why are we talking about these? Well, media coverage and public awareness about PFAS has really increased. So you need to be aware of these compounds. So if you get questions or if the media asks you about them. There have been several reports from environmental groups. One of the most recent ones is from the Environmental Working Group. And if you're not aware of that one, I'd encourage you to go look that one up. There have been a couple documentaries that have been recently released. One is The Devil We Know, and the other is Dark Waters. and they've both gotten media coverage. And then there's been recent coverage of the Department of Defense sampling at Air Force and Army bases where they have discovered some very high levels of PFAS. So the regulatory actions that have been taken in 2003 and 2015, companies voluntarily ceased production in the United States. Manufacturing has continued in other countries, and these products do come into the United States as raw materials that way and through various products. In 2013 through 2015, the EPA included 6 of the PFAS compounds as part of the Drinking Water Unregulated Contaminant Monitoring Rule number 3. And that was to determine the extent and levels found in drinking water throughout the country. In May 2016, the EPA established a health advisory that we already talked about for drinking water. In February of 2019, the EPA issued their PFAS action plan, and we're going to talk a little bit more about that in a few slides. And then in February of 2020, EPA issued a preliminary determination to regulate both PFOS and PFOA in drinking water. So in the EPA PFAS action plan for the wastewater section, it includes determining if there's enough available data and research to support the development of a Clean Water Act water quality criteria for PFAS. It also includes developing a risk assessment to better understand the potential public health and ecological risks associated with PFOA and PFOS in land-applied biosolids. And it also includes examining available information about PFAS discharges to surface water to identify industrial sources may warrant further study for potential regulation. So as a wastewater operator, you need to know that there's a lot of research being done, there's a lot of data being collected, and there's a lot of conversation about whether or not these should be regulated as part of your wastewater permit. So state actions, what I've just talked about was at the federal level. So at the state level, several states have established statewide drinking water MCLs or enforcement limits. Some states are starting to have wastewater effluent limits or guidelines. The state of Michigan has gone so far in that they have a discharge limit, an actual enforceable limit. Minnesota has been working on this since 2002. They have an area of contamination in the Twin Cities due to the manufacture of these compounds. And in February of 2020, Iowa DNR issued their PFAS action plan, and it's available on the DNR website. And the Iowa DNR is using the EPA health advisory levels for drinking water limits. And they do not have any limits for wastewater at this time. So if you're thinking about sampling and analysis, I want you to remember that these compounds are all around. So sampling and analysis are very challenging. You need to consider, why are you sampling if you're thinking about it? What are your objectives if you're going to sample? Why are you sampling? What do you want to learn? What compounds are you going to include in the testing? Remember, this is a group of more than 5,000 compounds. Which method are you going to use? And what are you going to do? Okay, hopefully I'm back. Not sure what happened there. So methods. So before sampling, you need to discuss with your lab the sampling requirements and your analysis methods. Currently, there are only 2 approved methods, and they're both drinking water methods. So one of the methods, it includes 18 of the PFAS analytes, and the other one includes 25 of them. So you need to understand that you're sampling for a limited number of compounds. There are a number of other methods that are under development at this time, and they include methods for wastewater, for soils and sludges, for air, and for plant animal tissue. Generally, labs are using the drinking water methods and modifying them for other medias. So if you're going to sample, be sure you get detailed sampling instruction from your lab along with your specific bottles. So remember, these compounds are everywhere. So some examples of sampling instructions. Do not wear clothing dried with dryer sheets. Do not wear water-resistant or treated boots or clothing. Do not use permanent markers to label your bottles. Don't use bottles or sampling equipment with Teflon coating, Teflon tape, or lids. And as an example, Michigan has wastewater sampling procedure guidance, because remember, they're the state with limits, and their guidance for sampling is 12 pages in length. So if you want an idea about what's involved, you can go to the Michigan website and search for their wastewater sampling and find those procedures. So with wastewater treatment, there is little removal in your process. You will see accumulation in your biosolids, but we're seeing PFAS found in both your effluent and your biosolids. And those concentrations are proportional to the concentration in your influent, which makes sense. We do find that treatment may change some of your compounds, but it doesn't destroy them. So typically what we're seeing is a longer chain, more than 8 carbon chains, shortened to less than 8 carbon chains. And truly what that means to you is you're seeing some of the compounds change, but they're still there. And remember, they bioaccumulate. So they don't degrade, but they do bioaccumulate, which means levels increase in people, in animals, in plants. They don't disappear. So there's a lot of concern about biosolids. So PFAS compounds have been detected in groundwater and surface water following biosolids application. And the main concern there is for drinking water sources and for surface water. We are seeing uptake in plants, and then as those plants are fed to animals, we see accumulation in the animals. We see it in fish, in meat, and in milk. There are a number of stories out there about milk needing to be dumped because of the PFAS levels in the milk. It also accumulates in grains, fruits, and vegetables. There's a tremendous amount of research being done, and you're going to hear a lot more about this to come. So there are a number of good resources. There are a number of good resources out there for you. Those include the EPA PFAS website, the Interstate Technology and Regulatory Council, ITRC, has some very good fact sheets and videos. They also have a very good table of state regulations. There's much ongoing research. There's research about the toxicity. You will go see, if you look at the table of state regulations, there are a number of different levels that states are regulating to. The 70 parts per trillion the EPA is using is one of the highest levels. A number of other states are down in the teens. So just be aware that there's tremendous amount of research being done about the toxicity. Also about testing methods and about treatment, both drinking water and wastewater treatment. Okay, switching gears a little bit about chloride compliance. So chloride, and we talk about chloride because it's toxic to aquatic life, both aquatic plants, invertebrates, including fish. It's a base compound, it's an ion, there's nothing for it to break into. and it's not removed from the environment. It's very mobile and it moves with water easily, and it's not removed in the wastewater treatment process. So this is just a graphic of the number of ways that we see chloride come into surface waters. So we see it through road salt. That's one of the large sources in the winter and spring. We see it through water softener discharges, and we're going to talk a lot more about that. And we see it through ag applications, fertilizer, manure. We also see it through dust suppressants, lawn fertilizers, and then we see it through wastewater treatment plant discharges. And as I said, it causes, and it's toxic to both aquatic plants, fish, the other aquatic life, and then we are seeing increases in drinking water because of the discharge to surface water and groundwater. So initially in Iowa, there was an interim standard for TDS, total dissolved solids. As there became more research, it was found that chloride and sulfate are better predictors of toxicity than TDS. So in November of 2009, the interim TDS standard was replaced with water quality standards for chloride and sulfate. So the chloride toxicity is dependent on the amount of sulfate and the hardness of the water. Generally, the harder the water, the higher the chloride level can be without causing toxicity. The standards that are used assume a default level of sulfate and hardness in your receiving stream, and that's based on statewide monitoring. So if you have an NPDES renewal application, part of that process is doing sampling for chloride levels. Chloride limits are included in your NPDES permit when your sampling data indicates a reasonable potential to exceed the standard. And compliance schedules are included if immediate compliance is not likely. So there are 3 primary sources of chloride in your wastewater. Home water softener discharges, and those are from the regeneration brine. If you've got municipal centralized drinking water treatment residuals that are a brine or a salty discharge, and those would be if you've got ion exchange regeneration, and there's some coagulants that are high in chloride. And then the third one is industries that use salt in their processes. Secondary sources, which are much smaller contribution, are personal care and household products from domestic wastewater and food waste. So if you have a chloride compliance schedule or are struggling with your chloride compliance, there are 11 options, and we're going to go through these options to achieve or maintain compliance. So the first one is to reduce your chloride in your influent. So you want to look at and reduce contributions from home water softeners, from municipal ion exchange treatment if your drinking water is using that type of treatment, and from industrial users. So from your industrial users, the best way to identify their contribution is to sample their discharges. If there's a significant source of chloride, significant level of chloride in their discharge, you need to work with that industry on chloride reduction options. And that can include use of alternative chemicals or use of different water treatment within their compound or facility. So ion exchange and water softeners they use an ion exchange process for the treatment to remove contaminants. So softeners remove hardness, calcium and magnesium, and or radium. If you're doing anion exchange, that removes nitrates. All of these methods use a brine solution from either sodium chloride or potassium chloride to regenerate the resin. These all are resin-based treatments. So in that process, you replace the contaminant that you're removing with sodium or chloride during the regeneration. And then during the normal process, during normal water treatment, that normal flow, you're doing an ion exchange process to remove that contaminant. So during that regeneration process or during the treatment process, you're getting loading of chloride to your wastewater plant. So home water softeners have been found to be the biggest source of this. So utilities really need to consider some options, and these would include encouraging your homeowner to maintain their softeners. So we're finding that poor maintenance, iron fouling, and resin deterioration causes more frequent regeneration. And the more often that they need to be regenerated, the higher that chloride load. You should consider encouraging your users to change to demand softeners. So these types of there's two types of softeners: time softeners and demand softeners. So time-based softeners regenerate based on time, every Tuesday and Thursday, or at a certain period, whatever their period is set. Some regenerate every day. Whereas demand softeners regenerate based on the level of hardness rather than time. So you need to encourage the use of those types demand softeners. Encourage your customers to soften only hard water taps, not cold water outside taps. Don't have them treat their entire or soften their entire home and their outside taps. You should consider educating your customers on the benefits of not softening to 0 grains, not softening completely. That will cause less corrosion to their internal plumbing and save them considerable amount in salt for regeneration. And then I'd encourage you to consider incentives to your customers to upgrade their softeners to demand type softeners. We've seen that work well in some communities. So for municipal water treatment options, if your system is doing an anion exchange process, which is nitrate removal, or a cation water softening, zeolite softening process, encourage them to look at how they're operating that. Can they replace that with other types of treatment? If you don't have that type of treatment and your customers all have individual softeners, think about installing centralized water softening treatment. So you control the water softening level and the operation and the maintenance. That would then replace the individual homeowner softeners. Treatment options for softening and radium removal and nitrate removal rather than an ion exchange process include reverse osmosis, RO, and for larger systems, lime softening. And then if it's a salt-based coagulant that seems to be causing a large influx of chloride, changing to one that is not salt-based can significantly reduce the chloride loading. And we typically see this at surface water, conventional surface water treatment systems. A second option is to reuse or recycle the water. So investigate if the effluent or the high chloride portion of the influent could be used for other purposes. So this can both reduce the amount of your effluent, which would lead to greater dilution in your receiving stream, or eliminate it completely. Options for that reuse or recycle could be for cooling water purposes, for livestock watering, and for other uses. The third option is site-specific limits. So remember that the chloride limit is based on the hardness and the sulfate level in the receiving stream. So if you sample for those parameters, you can provide data for that, your specific discharge site, and not use the state default settings. This would require you to sample upstream and in the receiving stream and your discharge for 1 to 2 years. So it includes monthly sampling for 2 years or twice per month sampling for 1 year. And for controlled discharge lagoons, you sample during the 3-month discharge period. And you would need to sample the upstream site during all 3 months of the discharge period, and then sample when you're discharging, and those are paired samples. That data is submitted to DNR for review and calculation to determine if they can revise your chloride limit. The fourth option is a mixing zone study. And so chloride limits are calculated based on the default mixing zone data. So for this option, you would conduct a mixing zone study to demonstrate the mixing that you get at your specific site. So there is a specific procedure that's described in the waste load procedure document that's on the DNR website. You need to discuss this with DNR staff. And if the study shows that your actual mixing, your dilution, is greater than the default values, your chloride limits may be raised. The fifth option is to pipe to a larger stream. So if you discharge to a small stream, consider constructing a pipe and discharging to a larger stream, as this may increase your chloride limit. So you need a stream with higher critical low flows. So remember, you don't remove or eliminate your chloride, but dilution lessens the toxicity. So the greater the dilution, the lower the chloride level in your receiving stream, and the less the toxicity. The next option is consolidating outfalls. So if you're in a utility or an industry that has multiple outfalls, combining these into one outfall may help you with achieving compliance. So this is particularly useful if your quality is different in your outfalls. So if you've got one outfall that is a high chloride level and your other outfall has very low chloride levels, combining them again is dilution. And so if you dilute that high chloride stream, you may reduce the levels to the point where your combined discharge meets the limits. So that's another option to consider. The seventh one is stepwide limits. So in this option, you would only discharge when the receiving stream flow is above a specific level. At this higher flow level, your chloride level would be diluted to a point where it's not toxic after mixing in the receiving stream. So factors you need to consider are if you've got enough storage for low flow conditions. So during low stream flow, you would have to store your what you would normally be discharging, and then discharge it when you've got higher flows in the stream. You have to have a way to accurately measure your stream flow so that you know what those stream flow levels are and when you are at the flow level that you're allowed to discharge. And I'd encourage you, if you're considering this option, to consult with DNR to discuss this option. The eighth option is to install a diffuser. So this includes installation of an in-stream diffuser to allow rapid mixing and again, greater dilution. So you need to remember that this diffuser has to be properly designed because what you're trying to achieve is rapid mixing so that it minimizes the toxic effects, and it also needs to allow for safe fish passage. So this option requires that you do a dye test or modeling or have other means to demonstrate that the mixing is complete within 100 feet downstream of your discharge location. There are several permits required for this in addition to your wastewater permits, and you need to contact DNR staff if you're considering this option. The ninth one is flow variable limits. So this would be that you would get different chloride limits to correspond with different receiving stream flows. So you need to think about when your stream flow is low, that your chloride limit would be lower. And so you would need to most likely reduce your flow or your discharge level at that time. So you would need to be able to show or demonstrate that you can meet your chloride limit at your lowest stream flow. You need to have a way to accurately measure the stream flow each day. I apologize for these technical difficulties. We are not sure what's going on here today. Hopefully it's just during my presentation and the rest will not have this issue. Back to flow variable limits. If you currently do not have flow variable limits, you would have to pass an anti-degradation review as well. So again, contact DNR staff to discuss this option. The 10th is disadvantaged status. So in this option, you would have your compliance schedule extended based on qualification as a disadvantaged community. So there is a very detailed flow chart that would walk you through what's required to determine if you meet those disadvantaged community requirements, and they're very specific requirements. So I would encourage you to contact DNR staff to work through that process and determine if you qualify as a disadvantaged community. The last one is a variance request. And if you have no other options, you can apply for a temporary variance from the chloride standard. This is a very detailed process. It requires approval from the EPA. It requires DNR rulemaking. And so this is used as a last resort after you have exhausted all other options. And again, I would encourage you to contact your DNR staff to discuss these requirements in this option. So I would encourage you always, when you get a new or amended NPDES permit, to read it when you get it. Make sure you go over it and understand what it includes. If you've got a compliance schedule, be sure to follow the directions and the requirements. So this is an example of a chloride compliance schedule. This permit was issued February 1st of this year. So you will see the first bullet point is this facility needs to contact DNR staff by May 1st. So within 3 months, this facility is required to contact DNR staff to schedule a chloride compliance meeting. The second deadline, or the second bullet, is within 3 months after that meeting or that deadline, they need to submit a chloride compliance strategy. So that has to be submitted within 6 months of the permit being issued. And that compliance strategy has to describe the steps that the facility will take to comply, and that they need to be in compliance no later than 5 years after the permit was issued. And then the facility has to submit progress reports every 12 months until they are in compliance. And it gives you the date that the first progress report has to be submitted. And so you will see that there are a number of dates here that the system needs to comply with. So you need to be on top of this. When you get a revised or new renewed NPDES permit, it looks like that achieved compliance date is a long time. It's 5 years out. But understand that this facility had actions that they needed to take within 3 months and within 6 months, and then annually submit reports after that. So it's very important that you read your permit, understand what that compliance schedule requires. I'm going to wrap up with a little bit about a new program. This is the high school internship program. And this is a new program that's just getting underway. It has 3 goals. They are to develop interest and awareness of water and wastewater industry and career paths for high school students. So one of the things we know is that there are going to be a number of openings, and we've not done a very good job of talking to high school students about water and wastewater opportunities and what those career paths could mean for them and what they even involve. So the second goal is to provide a paid internship for a student or students to learn more about the industry. And then the third one is to assist in succession planning for smaller communities without a current internship or training program. So this program matches a utility with a student. Currently, it includes $5,000 to be paid to the utility. There is seed money from IOWEA and in-kind donations from other organizations. It includes a 240-hour commitment by the student and the utility. It includes flexible schedule and flexible pay rates. Both the schedule and the pay rate are negotiated between the utility and the student. And it does include an application process both for the utility and the student, and for the utilities and student match, and that's overseen by the committee. This is the committee, and I'd encourage you to contact any of us for more details. You're going to hear more about this to come. We are hoping to get our first intern or interns placed this summer. The COVID-19 and schools being out of session for the remainder of the school year has created some challenges for us, but we're in the process of matching the first utilities and students. So if you have interest in being a sponsoring utility, please contact any of us, and we will talk to you about the details, provide you with additional information, and be happy to explain the details with you. I don't see any questions or any questions that have come in through the chat. So if you have any, I would encourage you to type them in now. And otherwise, I'm going to stop presenting, and I'm going to go ahead and turn it over to Dustin Miller at this time.
Well, thank you for that, Julie. And want to make sure, Julie, since you were the last one talking, can you see my slides?
I cannot see your slides.
There we go.
Yep, now it's loading.
Okay. All right. And can you see the first slide then?
It's loading. It's coming. Okay, there we go.
Okay. Well,
Okay.
Good morning, everyone, and thanks for joining us. My name is Dustin Miller. I'm a shareholder at the Nyemaster Law Firm in Des Moines. Nyemaster celebrated its 100th year as a firm in 2018, and I do primarily government affairs work for us. However, do a lot of our environmental work as well, both Clean Water Act and Clean Air Act. Prior to coming to Nyemaster, I was the general counsel for the Iowa League of Cities and helped develop the Iowa Nutrient Reduction Exchange, which I will discuss. Was involved in the league's litigation against EPA. And before that, I spent some time out in Washington, D.C. And actually implemented a lot of infrastructure projects with the Rural Utilities Service through rural development. So if any of you are accessing money through the Rural Utilities Service, I helped with the water and environmental programs, electric programs, and telecommunications programs. But most importantly, since I see Dave Judd's name on here, I am also the city attorney for my hometown of Lacona, Iowa. So I thought I'd give a shout out since I saw Dave's name on here. What I am going to go through over the next roughly hour, maybe a little under that, is specifically nutrient trading, what that means, and more so some innovation and potential resources for you to access. As Julie covered at the beginning, these are unprecedented times. I think we're all struggling to find a synonym for unprecedented, and you probably hear that word daily. So some of this stuff, you might be dealing with a daily crisis that you're trying to manage in your local community, but hopefully these are some resources for you to think about as you come out of the immediate needs and think about ways that you could potentially save yourself some money while achieving greater impacts. So what I'm going to cover are twofold. First, some policy innovation that may be able to access flexibility from the Department of Natural Resources and EPA. And through that, I'll cover the Nutrient Reduction Exchange, which is Iowa's version of water quality trading. I'll also cover integrated planning, which is a planning tool, which a lot of you have probably utilized that same thinking over a number of years, and your consultants have probably utilized. Now it is in the U.S. code and gives you a lot of flexibility to potentially save your community some money while achieving even greater environmental benefits. And Julie hit upon this, but the disadvantaged communities rule is also another tool available to you from a policy standpoint. Also, I thought it was also important to cover resources. People are always asking what resources are out there and available for my community and for my treatment system. I'm going to go through a few resources, some of which are directly eligible for your waste treatment plant. Some of them might be tangentially related but will impact your waste treatment plant, such as green infrastructure and other stormwater initiatives that may hopefully curb some of your peaks in your flow if you're dealing with a lot of I&I or other issues. But first and foremost, hopefully many of you are aware of the Iowa Nutrient Reduction Strategy. What I would say is the press that you see on the Iowa Nutrient Reduction Strategy is primarily focused, I've seen, on the agricultural aspects or the non-point source side. What I want to review here briefly is the requirements for waste treatment plants. So the nutrient reduction strategy is focused on nitrogen and phosphorus loading to the Mississippi River. The final draft or initial draft, since it's constantly working, a working document was in January 2013. The total goal is 45% for non-point source and point source combined. The issue in a state like Iowa is our non-point source loading is so much higher than our point source loading, which is fairly typical for any. It's almost universal for most states. However, if you've seen news reports about Chesapeake Bay and their total maximum daily loading, their TMDL, theirs has an opportunity that it's much more of a 50-50 split between industrial, municipal loading compared against non-point source runoff. In Iowa, the loading is very much on the non-point source side versus the point source side. However, it's important to understand in these point sources, especially if you're loading into an ephemeral creek or something of that nature, that it can have a large impact, especially if we're talking about winter time where a non-point source load is likely not to occur. Now, for those of you that are in smaller communities, it's important to understand that that there is only 100 cities that this is required. What I've put on the screen is a permit from obviously West Liberty. This shows up in all permits, new permits as they come out. I think we're close to, in the state of Iowa, all permits at least having this language initially put in them, which basically gives the overview of what the nutrient reduction strategy requirements are. Basically, the goal in the state of Iowa is a goal, and it's a technological requirement, and not necessarily hard written, So there's a lot of flexibility even within the strategy. Some people don't reach out and make assumptions that this is what they have to do. And what I would recommend is reaching out to a consultant to help you understand if this requirement shows up in your permit, what are the flexibilities? Because likely you're not going to want to spend multiple $1 million, especially if you did a recent upgrade to your plant, to just put on a new piece of equipment. And maybe you're dealing with I&I, or maybe you're a CSO, a combined sewer system, or maybe you're dealing with infiltration to the levels that it would make more sense to work on those things before you would put this in. So I put this here so that you know that there are a lot of flexibilities even within these permit requirements as you discuss with DNR. As I mentioned, the strategy is integrated between non-point source and point source. The non-point side has a science assessment that essentially looks at various different conservation practices. What's interesting about those is in-field practices, which are your prototypical nitrogen stabilizers, cover crops, things like that. They're annual practices based upon planting. When you start looking at the edge of field practices, I think when I speak with wastewater operators and engineers, what you find is the edge of field practices start looking a lot like stormwater practices in your community. So I think as I talk about a connection potentially between a municipal community and its larger watershed, I think you'll see that there's much more of an interest as you look at those at projects that are edge of field structured infrastructure based practices, because similar to your stormwater practices, you know what you're getting with it, as opposed to paying for, some communities have been asked to pay for cover crops, which is an annual cost, and then also with it being an annual cost, you don't actually know potentially based upon the weather what the actual removal amounts will be. On the point source side is a technology assessment, and as I mentioned, it's only for major waste treatment facilities, which means processing 1 million gallons per day, and considering biological nutrient removal as a technology in the future. What happens is an initial, as you'll see down there in the point source technology assessment, it's an initial 2-year feasibility study to understand what is your influent and your effluent. Iowa is one of the few states in the country that is actually having you test your influent and effluent. That's extremely important. Most states, it's only looking at what your effluent is. Here, you can actually look and see what the reduction is within your plant. So if it's coming in to your plant at a certain level and you're achieving a 50% reduction, that's valuable information, and you are well on your way to achieving the reduction goals of the strategy. The costs on the non-point side, which don't matter as much to you, however, there's 3 estimates from $1.2 billion to $4 billion. I put that on there just to understand the scale and the cost that the state is looking at. And as I mentioned, the cost and the need on the loading side is certainly on the balance of the ledger on the non-point side. On the point source side, however, with these permit requirements is a little more real, and there will be pressure as you get these permits to react to them and determine what's right for your community in implementing. Certainly, the majority of the permits have the technology available to essentially and potentially retrofit their facilities to address this. However, there are some smaller communities that may be having controlled discharge lagoons or aerated lagoons that ultimately won't have the ability to retrofit. And some of those are likely related to heavy infiltration issues around a town. But it's an overall strategy with a lot of flexibility. So if you're staring at one of those saying, how am I going to do it? It isn't simply just the black and white, what is written in your permit, but there's a lot of flexibility and opportunity to negotiate with DNR. And what I would say is DNR has been great through this process. The goal here is for everybody to try and achieve the goals, not necessarily to squeeze anybody into something that they can't achieve. The overall goal is a 60% reduction in your nitrogen and 75% in your phosphorus. There are communities, and I have that data if anyone is interested, after we're a number of years in this. We had the 5-year anniversary last year of the implementation, and we ultimately there's some communities that are already achieving the goals, and all they have to do is in the next 5 years in their next permit do the testing again to assure themselves that they're still assure the DNR that they're still achieving those reductions. As I mentioned, it's a 2-year feasibility study where then in your 5-year permit you determine when it would be affordable and available to do that. There's no set requirements, unlike other new policies with DNR where they're kind of set templates. They absolutely made it a goal to not create a template that everybody sent back to them the same information. Here you'll see a lot of variation between the feasibility studies, but ultimately it's up to your community. As I said, I've worked with a number of clients that they're interested in doing biological nutrient removal and getting their reduction, and I think for especially larger wastewater operators, they look at this and say, this is something that is likely to come anyway, so I might as well address it, put it in my infrastructure plan in the future in how I'm going to handle it. Then finally, all in this, the interest and the opportunity through people on AWEA and other wastewater operators that help develop the nutrient reduction strategy. There was always this interest in water quality trading, which has been bounced around since the mid-90s. And with the concept of, can I spend pennies on the dollar to achieve reduction on a farm field or on a park in my community, where it's pennies on the dollar compared to gray infrastructure at my plant. That obviously creates a lot of questions from a certainty standpoint and from a regulatory standpoint. But ultimately, if the overall goal of the state in merging the two non-point and point source, there certainly should be an opportunity where you have the ability to pay for those projects and achieve the same results if the ultimate goal is the loading to the Mississippi River. In Iowa, we've shifted that concept from a straight water quality trading, which, to be very honest with you, has not had a ton of success, and it's based upon some limitations that I will cover. So here's an overview of water quality trading. As I mentioned, in the mid-90s, there were a lot of people that started working on water quality trading, and so much so that in 2003, EPA actually created a trading policy. The main focus that people get interested in on water quality trading is between point sources paying a non-point source, likely a farmer, to have an offset. The regulatory benefit then comes back to the point source or the waste treatment plant. It's important to understand that in the mid-90s, up until this EPA policy, there was significant success when it came to point source. The concept being that economies of scale, large scale waste treatment plants could achieve greater reductions and spread the cost out more of technology to remove nitrogen and phosphorus, and could sell off their credit in that technology to another facility that has fewer people or technology is more limited for them to achieve the reductions. There's been a lot of success there on the point source side to point source. However, it's kind of the golden goose was always, how do you create interest and a structure that gets point sources to pay for these projects on a non-point source side. But that's essentially the basics of what people are trying to achieve, and it sounds simple, but allowing a point source to purchase credits to reduce pollutants that is, as I mentioned, pennies on the dollar compared to gray infrastructure at your plant. Previously, water quality trading, the focus has been solely compliance driven, utilizing numeric nutrient criteria and TMDLs. The problem with that is that it is extremely restrictive and had limited success. One of the biggest fights you get into is baselines, and baselines being about the non-point source producer, meaning that a farmer would have to implement a set of standards and criteria before they could ever work with you on developing a credit. Really what this looks like is a backhanded way for environmental groups to put restrictions on non-point source producers on the backs of a point source. It can be frustrating to look at the loading and you know what the impacts are. However, essentially you have to deal with the cards you're dealt. And what I always say is that unequivocally the Clean Water Act has been a success since the early 70s. But what I try and hammer into the policymakers' heads on a regular basis is it's absolutely been successful, but it absolutely has cost a tremendous amount of money for that success. So the big key here is to not create numeric criteria or TMDLs that are so restrictive that or technology that's unachievable. And in fact, a lot of previous water quality trading programs focused on what you can't achieve. And what the good folks at ISG can tell you is it's pretty easy to remove nitrogen. It's costly. Phosphorus getting down to a certain level is very challenging. If you use the base of what EPA set as a policy as their template, so to speak, Iowa is utilizing a goal of 10 parts per million for nitrogen and 1 parts per million for phosphorus. If you leave this to EPA, the number you will see is more in the 1 parts per million for nitrogen and 0.1 for phosphorus. There is not technology available. And that is essentially what other environmental groups pushed other states into pushing for, is you implemented the best technology available, and anything you couldn't achieve it would be what you could then trade as a credit. When I was at the League of Cities, we began working on this shortly after 2013. So you can see the language in the nutrient reduction strategy beginning in 2016 started to reflect those efforts. As I looked at all these, and certainly we had consultants from all around the country come to our doorstep at the League and tell us what experts they were in water quality trading, and what I found is there aren't a lot of experts, just simply because of these things that I'm talking to you about. And quite honestly, not being able to work with a farmer who is a renter, what I've always said is, to me, the science should guide where we place these projects. If we have a nitrogen and phosphorus problem on a particular piece of ground, I don't really care who owns it. I don't care what they're doing. I need to address the problem. And similarly, it just seems completely unreasonable to develop a policy where I'm trading away something that is not technologically feasible. So we really tried to think about this differently than these other efforts. And prior to coming to the League too and going to law school, I coached basketball for a long time, and one of the analogies I would always use is as I would use to my players is, I don't want to know what you're good at. I want to know what you're limited in. And that's really how I looked at these programs, is to not be dismissive as to their failings, but understanding their failings to try and set a policy in place for the state that would actually be usable. So that's where the development of the nutrient Reduction Exchange began. As I mentioned, it really was a process driven by the league from 2013 to 2018, and that is important. And what you would hear from DNR is one of the things that we identified is that other states, that it had been a regulatory agency driven process and not really thinking about how the communities would actually utilize them. For us, we tried to work directly with the wastewater operators in the cities to actually understand what would be useful to their communities. And in the same boat, we also included agricultural commodity groups and advocacy groups to understand what would producers see as an advantage. That was extremely important as we looked at that because, again, as I went to national conferences to get an understanding of water quality trading, that the key here is it's important to understand that while an edge of field infrastructure project looks very good to a wastewater operator because it looks like a stormwater practice, that actually has no economic benefit to a producer. So for them to spend money at the edge of field on something that they don't actually get to achieve can be a challenge. So how do you get that person to think differently is important. And having those two groups there to understanding the motivations and understanding a difference in thought process and worldview to try and develop a process that actually works. Throughout the process, we ended up getting flagged by the U.S. Corps of Engineers, and EPA's National Office and USDA's Office of Environmental Markets. And the RIBIT system, which some of you maybe have utilized, is the Regulatory In Lieu Fee Bank Information Tracking System at the Corps, is utilized mainly for mitigation. Wetland and stream mitigation. There is now a component that is for water quality trading and the nutrient reduction exchange, because what people had seen is spending millions of dollars on a new registry in one single state or watershed, and rather than doing that, trying to get the economies of scale at a countrywide level, on an EPA agency level to try and standardize that process. But the major key from a motivational standpoint for a waste treatment plant is, and again, this was important in getting the groups together, is your community, especially right now, doesn't just have extra money to throw around, especially for a project maybe a county away that you have a difficult time understanding what the benefit to your community would be. And I think some of the people that have done this in other states, that they really look at this from a speculative investment standpoint. And our goal always was, how do you achieve benefits for the wastewater operator and the community? However, as you'll see in point 2, you can ultimately utilize motivations and track multi-benefit investments. A goal for a community might be multifaceted, and it's kind of an Old Testament analogy for me. It's kind of a biblical aspect of, I don't really care the intent of your heart when you put in a bioreactor or a buffer strip. If it achieves multiple benefits, then we should track and understand what those benefits are. So you can see some of the benefits that we've seen in the communities as we develop this. Additional environmental benefits being important to some communities. Flood mitigation is probably the biggest aspect, that if you can slow water down, it might have a big impact in your more urban community. Source water protection for those of you that have source water issues for your water treatment plants. Economic development, some of these are related to daylighting sewers to try and achieve more quality of life initiatives. Habitat development, increased nutrient reduction, and increased production. Those are some of the motivations and multi-benefits that we were going to track, and that fits for both sides. For a farmer, they might want to achieve increased drainage in a project for their farm fields, which achieves greater productivity for their field. So utilizing those different motivations for a single project and understanding that somebody walking into that project will have different motivations was an important part of this. Also, this can't just be a back of the napkin. In some of the communities we initially worked with, that's the discussion was, hey, have you done projects? Yeah, trust me, with a wink. Let me scratch them out on this napkin for you. Well, that's not good enough if you're trying to achieve regulatory benefits. So what you could see is in the ribbit system, some of the things that people upload to try and track this. And then also we worked on integrating this in with your permit so that people felt more certain about the regulatory benefits they were achieving. And then how do you, if you're a small community and maybe you don't have access to a consultant, or you think you have a high capacity to do this modeling on your own, having the ability to submit those practices, but then also have the capacity at ISU and DNR to actually review and verify if those incentives are actually going to be achieved. As I mentioned at the beginning, the big key for all of us was, what is the incentive for investment from the waste treatment side? Why would you make this investment? And then as we got through in the pilot project is making sure that anyone could submit this, not making it a consultant-driven process or for any one individual or company. But if you have the ability to use some basic modeling skills, that any person can be able to make these submittals. The modeling also needed to be available to a broad breadth of people. And some of those models that have been used in but balancing that against models that have been used in other states that have a very conservative estimate as to their benefit. If you utilize some of the Russell modelings or Region 5 modelings, as they call them in other states, what you'll find is a bioreactor is not worth the money for the amount that you achieve. However, the beauty of this is, since it isn't directly regulatory focused, that it isn't about pounds like other trading programs, you can bring the model that you think fits best for your project. And what we've seen is there are modelings out there for bioreactors that does make a lot of sense. And then again, when you look at this motivation and multi-benefit, we're seeing cities that are interested in doing bioreactors simply because they can. The entire cost is about a $1,500 structure for the bioreactor, and then all you need is a team that's able to dig the ground, put the wood chips in, which are likely to be ash trees from your community you have to cut down anyway. So there's a real interest in achieving these things, so long as the benefit actually makes sense. If the cost outstrips the benefit, then it makes no sense. And I highly doubt that the environment is going to get changed purely based upon people's altruism. What you have to do is identify these motivations and then build off of that. And through our process, we had a lot of interest, both regionally and nationally. And in 2019, the Trump administration identified some of these hang-ups and restrictiveness that they'd seen in other programs. And when they released their concept, when they released a rule to achieve some comments to try and get rid of some of these baseline issues and restrictions that I covered, they actually included the Iowa Department of Natural Resources as part of the presentation to say the Iowa Nutrient Reduction Exchange is exactly the direction that the agency should go in letting the state decide this. You see, what had happened is this 2003 guidance came out, and rather than the agency and rather than states seeing it as buffers to then determine the policy that fit their community the best, people used it just simply as black letter of the law, agency included. So even if you were trying to achieve some flexibility from the agency, you didn't get that from the agency employees who treated this information in this policy document as black and white. The whole goal of the administrative approach in February 2019 from EPA was to say there is no law that guides this. There are certainly principles that you need to follow, but really you have to develop this in mind with your own community in mind and the benefits that you're trying to achieve. And a little graphic that we worked on that kind of goes through these things. A typical trading program really focused on the permit. And we didn't do that through this process simply because the nutrient reduction strategy was not a permit requirement necessarily, but really trying to look at the motivations that would cause people to make these investments. Here are the regulatory incentives that we discussed with DNR through this process. And let me just say, the Nutrient Reduction Exchange is available. You can use it today. While the project ended in 2018, 2019 in setting in place this in rivets, the whole goal was, again, not only developing it so that the state could, so the state could identify those things that were most important for the state in developing this connection between a non-point source and point source, but also individually tailored to the water treatment plants. So we put our thinking caps on and said, okay, if I were to make a buffer strip project a county away, and I'm looking at this from a flood reduction standpoint or source water, but here's the environmental benefits, the regulatory incentives that I want to achieve from the department. What are those regulatory incentives? And what you'll see is, and I'll go through these in more detail, but I'm happy to talk to anybody about them offline. But it's important to understand that you can go in and ask for any of these things, and we've gotten the DNR to say yes, they are. However, if no one wants to use them, there's no reason from a policy standpoint for the DNR to work to develop those policy tools to actually make them usable. So the first one that is being utilized in the current community that I will cover towards the end is the one thing that people wanted to see is you'll see these trade ratios being at a 2-to-1 or a 3-to-1 to essentially offset, performance. Your buffer strip doesn't perform the same year after year, which is why you model and determine this, error aspect. But what people wanted to see is to provide an incentive before this becomes a permit requirement. They wanted a 1-to-1 ratio for their projects if they build before it became a permit requirement. And this is something that DNR has said that absolutely they would go along with if people are using the rivet system. Second, the verified reductions may be applied by the point sources and offset against new and expanded loading. This could be, new industrial growth, new residential growth, maybe you're a growing community, that this could be used in that expanded loading scenario. This was requested by Cedar Rapids, who's obviously a heavy industrial loading community, but ultimately trying to look at this from an economic development standpoint for the state to make sure that a nitrogen or phosphorus level is not impacting potential new growth for a community. Also looking at something like an environmental excellence program that would allow people to maybe get reduced agency inspections because people are seen as an environmentally positive community, and trying to give people an incentive for doing these additional investments. And you can see, I won't go through in detail, but ultimately trying to look at your watershed, trying to develop future baselines, and then also looking at priority scoring. The sponsored projects program that many of you have probably looked at, where you get an interest rate reduction and be able to achieve an additional watershed project. Thinking about receiving priority scoring, or even a mandatory amount of investment from the state if you were to do one of these projects. There's even been discussions with agencies about if a project, a sponsored project is in your town, great. You achieve that benefit through the SRF. However, if somebody thinks about doing a source water protection project that is outside of their city limits, that maybe potentially the Iowa Department of Ag and Land Stewardship, that they match you 50 cents on the dollar to actually even boost your project further. These are the kinds of thinking and innovation that are available. It's a matter of a community walking in and saying, I would like to achieve this benefit, and then that ultimately kickstarting the agency into developing the tool to give you that certainty against that benefit. The most recent aspect of water treatment just happened last month, where Dubuque has put together a memorandum of understanding with DNR. This has been utilized or looked at in other states, but this is basically Dubuque's approach to utilizing these regulatory incentives that I just covered. For them, they were comfortable. Some communities are saying they want these incentives and these regulatory benefits in their permit. Dubuque was more comfortable in negotiating it and developing it as a memorandum of understanding. How you do this is really community dependent. What I would say is, make sure that you're working with legal counsel and engineering consultant to understand, first of all, the background of the Clean Water Act and how these things work. But certainly, as you can see, there is a lot of flexibility on the part of Department of Natural Resources for people to achieve the benefits that they have been identified through this process. Next, I want to go through another policy that can provide some flexibility, even if you're staring at a pretty high level consent order or admin order. There are tools available to you that since 2011 that can help you think about potentially offsetting the costs, so long as you look at those costs really from an overall environmental benefit standpoint. And really, again, similar to the discussion I just had on the nutrient reduction trading, it's really in the eye of the beholder. You might be looking at what I will cover here on integrated planning from a can I extend out my schedule and save my citizens some money? But ultimately, you have to look at it from the view of doing that. Are there things that I can do along the way that actually achieve additional or different environmental benefit? So integrated planning, while was very exciting for people in 2011, the previous administration released this memo that said you could achieve water quality through integrating your municipal stormwater and wastewater plans. And that seems to make sense. As we all know how your systems are structured in your communities. Maybe you're in a small community and your water treatment plant, your wastewater plant, and even your limited stormwater are all run by the same company or the same authority, or just maybe under the city council. As you get into larger communities, I'm sure you run into these situations where it can be much more territorial and fiefdomish. But ultimately, the overall concept makes sense. That if if you have water that is regulated in your community essentially by the same agency, the EPA, then that regulation should think and talk to one another. And that's the whole concept of integrated planning, is to try and think of your regulation from the EPA in a more thoughtful, holistic manner. And as I mentioned, the key here is to not say I'm not going to do anything to impact my water and wastewater, but it's prioritizing the sequence to achieve environmental benefits. And then ultimately looking at this from a cost-effective standpoint. And you can utilize the existing regulations and policies, and you will see in this memo that was released in 2011 and future regulatory tools as they came out, that even if you have an admin order, even if you have a schedule in place, a compliance schedule, anything is up for flexibility. What I will say, though, it is much more challenging if your admin order is with the EPA itself rather than DNR, and certainly if you're looking at a high-level consent decree where you're talking to the Department of Justice, which isn't a lot of people, but if you even have an admin order, I think some people get scared off that they would be able to achieve some of these benefits, and I just wanted people to understand that no, that these things are still available to you, even if DNR is leading things, and seen a lot of flexibility from the department and willingness to work. If you go in and say, well, we haven't spent anything in 20 years and we don't want to spend anything for the next 20 years, that's probably not the best approach. But if you walk in and say, we want to achieve the benefits at a manner that our citizens can pay for, that's a much better approach, and you'll see a listening ear from the department. Obviously, the goal here is a focus on stormwater and green infrastructure. As I mentioned earlier, that sort of focus, hopefully when you're looking at your stormwater and your green infrastructure, has a positive impact to your overall waste treatment gray infrastructure aspects. I'm negotiating an integrated plan right now with a community that is a CSO, and that's our whole goal, is to extend out the schedule, to put in place some green infrastructure, stormwater aspects to try and reduce the loading at the waste treatment plant. Obviously, that takes time and takes a lot of monitoring, but a pure city of Des Moines is a prime example. A pure separation of the downtown city of Des Moines would cost so much that the term that Adam Schneiders, that many of you interacted with, that I hear all the time, is the juice isn't worth the squeeze. Spending that amount of money on simple separation means that you can't spend money on nutrient reduction or any other benefits that the DNR is trying to achieve in their priorities. So after in 2011, after the memo came out, the EPA put out a framework to do this. The framework outlined a lot of what I'm saying, allowing flexibility. It allows structuring and proper sequencing, and it encouraged all this utilization. It's trying to balance the regulation with the realities of how you end up paying for these projects. It also said, exactly as what I had talked about, that this could include sanitary sewers, CSOs, municipal MS4s, waste treatment plants, but it doesn't have to. And so outlining all these flexibilities, putting in sequencing, putting in major things was extremely helpful. The problem is, I think, as you've seen with regulation, if you've been in this business for a long time, as you've seen with regulation from the EPA, these were memos. And they were not law, they were not regulations, and so I think people were very hesitant to raise their hand and say, please pick me, because they were worried as to what's going to happen in the future without something that's more solidified. But here are the elements that were put in place, and for people that have looked at this or are looking at this, it can be as complicated or as easy as you can make it. And I will give you a couple examples from the Midwest that really look at it from that vantage point. What you're going to hear from DNR is to follow this initial framework if you were to request this, and basically filling out a narrative on the elements that I have there on the left. What is the water quality, human health, and regulatory issues to be addressed in the plan? Again, I can't stress enough that your motivation to do this is likely from a rate increase standpoint. However, you have to really flip your head around and think, okay, what is the environmental benefits that I can sell that are actually going to happen better, be improved? And I'll give you an example of that, of a smaller community and a larger community in a minute. But these are the tools that you have on the right side at your disposal. As we develop an integrated plan with multiple other cities, if somebody has a compliance schedule, if somebody has an admin order, we develop the plan and then work on those additional tools to include those. What you're going to hear from DNR2, a big portion of this is point number 3, the community engagement, making sure that your community is involved, and how are you going to monitor this in the future? We've actually utilized that in some communities as we work on these. We've utilized it to help improve our plan and achieve longer term schedules, because I think ultimately looking at a plan over 50 years, things will change, and identifying that and saying, okay, after 5 years of working on I&I or separating some sewers, at 5 years of that, we're going to look back and see what the next 5 years should look like. You're going to generally know what are the different projects that you want up front, but being honest with the department, they've been very open to thinking about what does this look like in 20 years and 30 years that you just don't know until you do the work at the front end. And this gives you the ability to put that in a narrative and achieve it. One example in the community locally in the region is Springfield, Missouri. What I would say to you is this is the long end of it. There's if you click on their website, is very detailed. Took multiple years of developing and included a lot of impacts that you might not care about in your community or the citizens don't care. But this is just one approach. And you'll see it's extremely detailed, took a lot of thought process, took a lot of stakeholders. And this is what I would say if you're trying to initially look at what you could do. This would be at the high level scaling up and to include even air and other environmental benefits. The easier example, and if anybody's interested in this, my email's at the end, and you can email me and I can send it to you. The city of Boone put one in place in about 2015 timeframe. What it essentially looked like was probably what you guys are doing in a lot of your permits anyway, is kind of a CIP schedule or their infrastructure schedule, being thoughtful about where the investments will occur, and then writing a narrative around it as to why they think they should be able to inspect it. You could see their big key here was on UV, on disinfection, and really what their whole goal was to try and kick that out in a way that fit within their larger city budget for their citizens from a rate increase standpoint. They also had significant I&I issues, and their justification was to try and knock down a lot of the I&I because their storm surges were so huge that if they could knock down the I&I, that by the time they were to size their UV technology, it would be in a much better place. Now, that was their ultimate motivation, but the narrative, from FY17, you see there, to the UV disinfection, was all about achieving a better benefit of knocking down I&I and other environmental benefits. This is probably a 7 to 10 page document in comparison to the in comparison to the Springfield one that would be multiple hundred pages of documents in multiple years. This is essentially a compliance schedule that many of you worked on, I'm sure, across your communities, just done in a fashion that puts more narrative behind it. The advantage is obviously it reduces your cost and can lengthen time frame. And you can utilize nutrient reduction, exchange, those sorts of things to achieve other community benefits. What we're seeing too is people wanting to integrate some quality of life aspects of stormwater improvements and that, where, as I mentioned, daylighting a storm sewer where all of a sudden you have a nice amenity in your community, and improve water quality and environmental outcomes, and then ultimately better meeting your regulatory requirements. One of the arguments I've had with a client with DNR is, if all I'm spending money on in separating a CSO, I have zero other money to spend on disinfection, zero money to spend on water quality, other water quality aspects. Real briefly, the Disadvantaged Communities Rule is a tool that's out there to you. I don't think it's as useful as integrated planning. However, it is available. What I would say is Disadvantaged Communities Rule is probably more useful for especially small communities around the state. You know, we have first of all, we have 940 some cities across the state, and about 500 of those are under 500 in population. Those smaller communities, this might make more sense just about delaying some requirements. But it's the delay is limited. So if you're really looking at a larger system with longer term delays and aspects, I would really push people towards integrated planning. I wanted to cover some resources because you know, it's not enough to just tell you, you know, here are some policy solutions. At some point, whatever you commit to with DNR and the EPA, it would be nice to have somebody pay for some of that. As I mentioned, the water and environmental programs at USDA Rural Utilities Service, those have population threshold restrictions. For the grant portion, it's fairly low, but I'm sure many of you on the call have utilized some USDA Rural Utilities Service funding, which are loan and grant based. As I mentioned, the grant is restricted based upon a size. WIFIA is available. What I would say with WIFIA, though, is this is generally, I think, above $50 million for a project. This is another fund available. And honestly, unless you're trying to do something extremely innovative under WIFIA, our state revolving fund is operated so well, and the interest rates are so low, I would probably direct people to our SRF, just because of the thoughtfulness as to how it's been operated and developed in the state of Iowa. Our sponsored project program, you know, we were only the third in the country to do this. And what's interesting is we were the first to allow for sponsored project for those projects to be outside of city limits, which is a real innovation around the country. That kind of happened accidentally where the Rathbun Rural Water Association wanted to do source water issues because of a massive phosphorus problem they had, but certainly has allowed all of us to do some innovation, especially on this concept of thinking about the nutrient reduction exchange or water quality trading. And I'm going to go through in a little more detail on some of these others for the Department of Ag's Water Quality Initiative and other programs that came out of some legislation, the Senate File 512. These are specific resources that their full ramp up actually happens this fiscal year. The Department of Ag will have $30 million this year, and don't think just because it's the Department of Ag that there aren't resources there available to your community. So the legislation that came out in 2008 had in these slides, I'm sure ISG will make available to you. You're welcome to have them. This just gives you a broad overview as to how the money will flow to you and to the projects. but specifically how the projects were identifying the existing programs, which is a cost share, which would not impact necessarily urban communities, the Water Quality Initiative, which is an annual appropriation at the state level of roughly a little over $10 million, that has an urban infrastructure component that's been paid for since there, and then some other aspects that have been paid into since 2013. Those were things that were existing. What was created in the law were some edge of field. This is all non-point source, so I'm not going to go through in detail, but this is where your opportunity in a project where you're thinking about the edge of field infrastructure. This is up to a 90% cost share, so you could actually achieve a project upstream or in your watershed and pay very little to actually achieve the benefit back from the Department of Ag and Land Stewardship. This can also be utilized in a demonstration project. These are HUC 12 related on the demonstration project side, HUC 8 related, and you can see, and maybe there's an opportunity if you continue to look at the updates on IDOL's site to see opportunities of existing projects that maybe you could partner with ideas in your community. But here are the major things that are now available to you that weren't 2000. First and foremost is there is a new state money only revolving loan fund. It's important that it's state money only because it has the ability to not have to utilize Davis-Bacon, American Steel Act. So some of the benefits that you're trying to achieve, even just from a regulatory standpoint, that might save you a little bit of money. What I will say is there's a little frustration in the law because it has a trigger for this 3/8 of a cent, this I will funding. So the ability to leverage has been limited, and they've been having to wait for the appropriation. With a slight law change, that $51 million could be leveraged and bonded against immediately and look more like $151 million. Eventually, what this will look like is giving lower interest rates to achieve and to incentivize people for certain types of behavior. But until it is mature, it's just going to be have some limitations. But the one thing that I really wanted to make sure that you were aware of is as funding slowly comes into IFA, there is a grant program that are capped up to $500,000 that will be coming out through IFA that came through this. The money is slow, but as I mentioned, the full ramp up is this year for the program and runs through 2029. And for more information, feel free to reach out on that. And finally, there is the Urban Conservation Infrastructure Program that IDOL's had under the Water Quality Initiative. Now through 2029, the Department of Ag will have an additional $17 million to put towards urban infrastructure. These have been used for permeable pavers, for buffer projects in parks, but there's a whole lot of flexibility available to decrease erosion, but the whole focus being on water quality. So I wanted to leave those resources with you. My contact information is here. If anyone would like to reach out on any of these subjects, I'm happy to take it. And I don't know if we have any questions, but I'm happy to take them, ISG guys.
Thank you, Dustin, very much. I don't see any questions that have come in. So we appreciate it very much that you gave us all of that information. If people do want his slides, feel free to reach out to us. I do have them and we're willing to share them since he's given us that okay. If you signed in with a phone number and not your name, as a reminder, please send us an email and match up your name and your phone number so you get CU credits. If you don't do that, we don't know who's who and we can't give you CU credits. So please do that during the break or immediately after this. We are going to go on break. We will be back at 10 o'clock. And at that point, if we have questions, we'll answer those. Otherwise, we'll go into our next presentation. So return please at 10 o'clock. Thank you.
We'll get ready to start here. Hey, Julie, can you hear me?
I can, Brent, and I can see your slides fine.
Cool. All right. Right about 10 o'clock. So we'll just go ahead and I guess keep going with the webinar class. Very excited that we still get to post some training capabilities with all the COVID going on, and presenting from my house right now. So I saw Dustin shared his camera. I won't do you guys any favors by sharing mine to show my haircut that's 9 weeks overdue. If there are any questions, just post them in the chat. I don't think I can necessarily see those, so I might wait till the end of my slides to answer those questions. But if someone wants to chime in, if a bunch are coming through the chat, just go ahead and stop me, and I can answer those as they come. So right now we're going to talk to you guys about collection systems and I&I, jumping into presenter overview. Myself, my name is Brett Page, civil engineer with ISG. I've got about 10 years experience in the water resources industry. I've worked on collection system studies over the years of various sizes, ranging from small to large, up to 6 million feet of sewer. I spent some time working in Kansas City for a few years prior to 2015, specializing in hydraulic modeling and helping out develop industry standard flow analysis methods and techniques through pilot I&I programs. Down there, they had tremendous combined sewer issues. I think $30 billion was programmed to work through the city and separate their systems. So using some of those flow analysis techniques on a large scale, I've worked on separate separate sewer systems and also combined sewer systems for capacity and I&I reduction. Going to be talking today on collection system analysis and modeling, and Shane Jacobson with Central Iowa Televising. He's the Chief Operating Officer and Business Development Manager for CIT Sewer Solutions. He's got 22 years of experience in the sewer industry. In 2007, his dad and him started CIT and began working full-time as an operator and inspection work and CIPP repair installer. Shane works with engineering firms, municipalities, contractors for collection system maintenance projects, I&I studies, cross-bore prevention, and combined sewer separation projects. And he's going to be talking to you today about some of the I&I reduction strategies that are available and some of the maintenance procedures that entails. So jumping into my piece here, some of the objectives to define up front that we're going to go through. Lots to run through here in the time slot that we have. So I'll try not to be too quick, make sure that we cover everything. So components of flow in a collection system, kind of a basic introduction to what we're looking at as far as the water that's being conveyed to the treatment plant. The evaluation process that we typically follow to evaluate a system and prioritize recommendations, collection system flow analysis methods, and then how we use modeling to evaluate capacity in a sewer system. Sewer collection systems, they're a conveyance network designed to collect and move flows to a downstream treatment facility. So anything that gets moved from point A to point B throughout the city down to the treatment plant. It's a network of pressure and gravity pipes to do that, to convey the wastewater. And there's really three types of systems that we look at. There's a separate system where you have an isolated sanitary network and storm sewer network. They flow just in their isolated pipe networks throughout the system. A combined system where we have clear water entry getting into the sanitary. Systems are typically sized to be larger to handle that peak flow, and then a partially separate system, or maybe some areas of town we can't get those combined connections off, and we just leave them connected to the sanitary. So I pulled this graphic from the EPA's website. It's a holistic view, and it's a nice graphic. A lot going on of the various components in a sewer system. Treatment plant down here on the right, and it just kind of shows sanitary, some restaurants, businesses, any of your residential housing connected to just the sanitary line, and then the stormwater network being completely separate, running to the river. Some systems are sized or set up with facilities that if the flows get too high, will directly discharge into the river for an overflow. Up here, it shows a combined sewer system, how that's really set up and designed to handle residential housing, any commercial and industrial facilities that'll convey to the treatment plant, anything that would inundate the system, be more than what the treatment plant can either handle or the pipe network can handle, will just bypass and directly discharge to the nearest stream or river. Just kind of a quick representation to get a view of what we'll be talking about in a few short slides. Components of flow in a collection system. We have our dry weather flow, which is our low flows throughout the system. Rainfall induced inflow and infiltration, so the peak flow that is really related to rainfall activity, and then slow infiltration relating to groundwater conditions and below surface water entry. I wanted to show this graphic. We'll talk about flow analysis in a little more detail shortly, but kind of get a representation before we dive into some of these particular pieces. What we see when we're collecting data in a sewer system that has tremendous I&I problems. You can kind of see, we plot out the dry weather, get a low flow comparison of what our base flow actually is, to see the severity of what we're getting into our system beyond what actual wastewater production is. So the green line is representative of flow meter data of an actual system being monitored. At the top, we'll plot rainfall, so you can see as the rainfall intensifies, we get peaks in our flow, and as it gets really intense up here, the peaking factors grow exponentially. So three components we'll talk about: the dry weather, just the base low flow, the peak flow, the rainfall induced inflow and infiltration, that quick flow into the system from a rainfall event, and then the infiltration, for the slow infiltration that would be quantified after the rainfall event subsides relating to elevated groundwater conditions in and around the sewer. Dry weather flow, by definition, refers to wastewater flow in a sewage system during periods of dry weather with minimal infiltration values. So that low flow is what we're looking for. It's residential and non-residential wastewater use. We're looking for wastewater production only and no stormwater. And I found a slide that I could throw a picture of my 11-month-old son up here. He's learning to brush his teeth right now, and he's got 4 teeth, I guess. But just an example of some of the things that we do throughout our daily lives, what we consider just wastewater production: brushing our teeth, going to the bathroom, showering, doing dishes. That's what we're accounting for our dry weather flow into our sanitary sewer systems. And we'll quantify this during the lowest flow, driest month throughout the year, as we're looking through data to try to get that base flow established. RDII definition: it's a portion of water in a sanitary sewer system that occurs during and after rainfall. Take it back to that slide that we're looking at with flow data. It's the main cause of sewer overflows and basement backups. Puts a ton of stress on the system as far as flow components. It puts the max stress on your collection system network, and it's the fast component of clear water entering a sewer network that reduces capacity rapidly. Some of the sources, there's variable sources that can be attributed to some of the peak inflow into a sanitary sewer system, sump pumps, roof drains, surface voids, missing castings, and I just wanted to touch on sump pumps. Somebody's typing. Sorry, am I getting questions? Okay. Sources, I wanted to touch on sump pumps. Recently had a project that we're looking at some of the connections to the sanitary sewer system at particular locations. Areas that are flat, don't have any storm sewer that's relatively close downstream. There's really two options with some of those discharges. They can't discharge to the yard. That'll just recharge the groundwater, and the cycle will never complete until, I guess, the groundwater levels drop enough. But two outlet options. You can run it out to the curb line and do a curb knockout, and then maybe the nearest downstream sewer can pick it up, or it's connected to the sanitary. And some of the issues that we run into, these sump pumps, there's variable design components, but some can get up to 70, 80 gallons a minute. And if you get several houses connected to a sanitary sewer system, they're not sized to handle that. And that's going to result in quite a bit of capacity reduction, and could result in basement backups or overflows, in the adjacent network at those locations. And I just wanted to talk about a sewer study I was working on in Des Moines back in 2015. So it was a combined sewer system located near 235, adjacent to MLK, and just going through trying to separate as much as we could. The stormwater intakes are connected directly to the sanitary sewer system. That picture in the top right, you can see, the water can't even get in there. The sewer is so overwhelmed, and that's just kind of an idea of what happens and how quick or how much water can try to enter a sewer system, and the problems that can result from that. Water running down the street, it's almost like a river. The big picture that I'm showing here, just kind of a quick funny comment, I guess, maybe not for the property owner, but I did meet the property owner out at this address and talked about some of the issues that they had. And he mentioned every time it rains, an intense rainfall, his yard will fill up pretty much like a pond, and he'll have to open his back door to drain his yard down into his floor drain, which that's another source of water getting into the sanitary sewer system that it's not designed to handle. The severity of these problems are variable depending on the network, but they're clearly apparent in a lot of systems. Infiltration really related to groundwater that's entering the sewer from below surface, defective components, any broken pipes, things of that matter. Typical levels will be elevated after a rainfall as the groundwater recharges. Some of the sources, age of the pipe, that's not necessarily representative of a condition, but it can be depending on the material, offset joints, any poor installation practices as far as maybe poor bedding, causing the pipe to collapse or offset when it shouldn't, damages roots. Any of these can be infiltration sources from elevated groundwater levels. Impacts of excessive I&I, we have inflow or increased treatment flows to the plant, overflows in our system that are backing up into basements, out into the street, to the surface, reduced capacity of our network. And you can almost think, all this flow that's getting into our system, the RDII or the peak inflow doesn't all get to the plant, but it does, a big chunk of it will until the sewer system backs up. But you can think of that as how much extra flow we're having to treat, and the dollars that accounts for. And the infiltration, it doesn't necessarily inundate the system to a point where there's capacity is completely lost. Over time, there's a lot of volume on a monthly basis, maybe. Over time, that's going to account for a lot more treatment volume through the plant. So it does have some issues as you quantify some of those values. picture of a basement backup. That's not good. So it's just an example of some of the problems that, from a private resident standpoint, that can happen from a system that has a lot of I&I or a large peaking factor in the system. So where to start? Identify the goals of the project, what you're trying to do. You want to reduce the volume of flow to the plant for treatment dollars, reduce the severity of basement backups or overflows. Commonly, both can be achieved through the same processes. Begin to assess your system holistically. And you can also, if you have areas that you know are worse than others, you can strategically target those areas for some evaluation and inspection. And talk to your engineer, have that conversation and just try to understand what the next steps are and how we can help reduce some of the severity of I&I in the sewer network. Kind of a flow diagram of a standard evaluation process. We'll start by reviewing system information, identifying goals, selecting the areas that we want to maybe flow monitor, installing some flow metering equipment to collect that data and evaluating that information that was collected and trying to quantify the flow metrics that we just discussed. Shane will talk about some of the inspection and rehabilitation for I&I reduction strategies. He'll talk about those boxes during his slides, but we'll take that flow analysis, those components, and plug them into our hydraulic models to evaluate capacity, and then ultimately end up with improvement recommendations to a system. Flow monitoring, as far as installing a rainfall gauges to be able to represent actual wet weather that occurred in that system is important. Don't just rely on local and national reported data such as weather.com. It's good to have real field rainfall gauge data that's associated with the flow meters that are installed. And general rule of thumb is every 5 to 10 square miles, just to have a rainfall gauge to associate with the flow meter data that's collected. We'll delineate subsystems to target smaller sewer sheds. Recommend a minimum of 3 months of monitoring to make sure we get as much wet weather activity as possible, and to be able to see that system respond to rainfall and elevated groundwater levels. This is just kind of an example of a large subsystem. I think this is in St. Joe, Missouri. But there's a trunk sewer here on the east side. You can see as we delineate out, each one of these subsystems is completely isolated with their outlet down here on the east side to the trunk sewer here flowing south to this lift station. There's no cross flow between these subsystems, and we can isolate these and be able to maybe pinpoint problems based on subsystem or just on the level of effort that we want to target for certain areas. Flow analysis, we're looking to quantify sewer flows using rainfall depth and intensity data that we collect from the flow monitoring process. And we'll utilize graphical displays of information. And then there's several ways that engineers will evaluate some of this data. Some are more complex than others, and just two that I'll touch on briefly that I've used when I was working in Kansas City and recently as well, the inflow coefficient and then the RTK. So inflow coefficient, it's just a composite of the rational formula. We're looking to calculate our flow rate based on a runoff coefficient and then rainfall intensity as an area of the sewer shed. And we'll select storms that meet our criteria, throwing out outliers, and we're going to plot our flows versus rainfall intensity for each storm onto a graphical display. And so this is really the final output that we get from running through that analysis. We have the triangles here are representative of individual storm events that were collected during the monitoring process. We'll be able to turn some off. What we're trying to do is get a linear relationship of what rainfall actually was for that storm and the flow that we collected, and then we can extrapolate that out to project for planning information what flows we can plan for for some theoretical storm events up to a 10, 25 year event, and then we'll plot the capacity of the outlet pipe here horizontally, so we can see that this particular sewer network has a capacity of just under a 25-year storm event before we start to overflow into the street or up in the basements. RTK is another one. This is based on 3-unit hydrographs. We're looking at rapid inflow, so that quick response that we see, that we get a peak very rapidly just after the rainfall. The moderate infiltration, once that starts to subside, that piece that's just after the initial peak, and then the slow infiltration. These 3 triangles will sum together and we'll get an overall flow. So we're trying to break out those components into the system to see how it responds. And then R is just the fraction of the rainfall over the sewer shed that enters the collection system. T is the time to peak, and then K is the ratio over session time to peak. And each one of these triangles here are representative of that Q1, Q2, Q3, and these are the variables that are used to calculate what we're getting for those flows, and then just an overall, when we sum them together, we get an overall a QRTK, I guess would be the term for it, of what we're looking at for a flow in a system. And both of these are, you can find more information about these out on the EPA's website. I could probably talk for an hour on some of this stuff, but. So what are we trying to do with this data? We want to determine base flows, what our dry weather is, establish our peaking factors, projections for theoretical events for future planning, as developments grow out, or just wanting to see what would happen based on a theoretical, say 50-year storm, what would happen to a sewer system under that criteria. And really we want to look at capacity. Where do we have bottlenecks in the system? Where are we restricted? Opportunities for upsizing and things of that sort. So basics of hydraulic capacity. We're in a sewer system, average daily flows. We're looking at average daily flow plus infiltration. Pipes can normally handle that, and then seeing what happens when we add in the peak flow, and with everything together, does the sewer network or a particular pipe have capacity for those flow parameters? And just a quick rough check, I guess, or a basis of what we'll talk about in a minute with the hydraulic modeling. We can look at an individual pipe network using the Manning's equation, looking for flow rate, based on your pipe slopes and area and hydraulic radius in your pipe. It's important to watch the units as we're doing hand calculations. If you have something that's in inches when we're running it in feet, it'll throw everything completely off. The results will not seem right. So just watching units as we're running through an equation like this, just for a quick check. Varying slopes result in varying capacity, and wanted to show this graphic from just a hydraulic model output. I guess we'll talk about that here in a minute, but you can see is similar pipe, same pipe diameter, running down here, and you can just kind of, the purple line here is representative of a hydraulic grade line. The steeper that is, the more restrictive that section of sewer is being on the system. So you can see as the pipe is flatter up here, you have a little bit more capacity, less restriction, or sorry, a little less capacity, I should have said, and more restriction. And as we dive off with a higher slope, we gain a lot of capacity. So just kind of a visual representation of how that Manning's equation really works from a real world perspective, based on a profile in a sewer network with flow running through the pipe. Hydraulic modeling, we're using computer-aided simulations, based on the user input criteria, building the network from shape files and things. We're doing 1D hydraulic model runs, and that's really what's shown here in the figure on the right. You see the 1D network with the hydraulic grade lines that we're looking at as far as restriction in our system. Where are we seeing surcharge? Is the system flowing unrestricted? Those are just some of the things we're looking for. But what we're trying to do is push flow into a system to see how it responds. What's the severity of, or what are the consequences of certain flows as they get applied into a sewer network. And we're calibrating that to real-time flow meter data to make sure that the model results are accurate and representative of the system that is being modeled. And just one, I guess, rule of thumb as far as this really applies to any type of modeling, not just collection systems, but to question everything as you're building these things, running the models. If something seems off, make sure you look into that error, or if just verifying the results. That's just one good practice as we go through and run some of the models for any system for that in that regard, to just make sure that you assume everything is wrong until you know it's right. Why do we need hydraulic models? Collection systems tend to be pretty complex. It's not just running down a pipe network. Typically, it's system wide. Even on the same pipe network run, you can have varying slopes, pipe sizes. So it's we like to use these programs to simulate hydraulic calculations on a mass scale with a click of a button. We're doing it to understand the system, identify problems. Maybe once we have a calibrated model, we want to see what some alternatives look like as far as some improvements, and then we can also use them to supplement and verify any design that we're currently working on for that municipal sewer district. Standard objectives, we're wanting to look at capacity. Where's the system restricted? We're wanting to evaluate frequency and volumes of overflows, whether that's in the basement or out into the surcharged out of the system onto the surface. Identify system improvements relating to capacity, and then alternative feasibility. We can get into some cost analysis as far as value engineering and trying to utilize the model to help us pinpoint what's the most cost-effective solution for an improvement, and addressing basement backup issues, and then reducing flooding if that is a problem. So building some of these networks, we're going to use GIS data if it's available. AutoCAD or CAD data is good as well. Plan information that's available, we'll supplement some of this with survey, verify any special structures, or maybe there needs to be there's some missing information that needs to be verified. Sewer shed hydrology, what's the time of concentration that we're getting? How quick are we getting those peak flows to that location? And that can be identified during our flow monitoring and flow analysis processes. And then we want to estimate flow values. The estimated flow values from the analysis output, we'll use those to build our model and create the system flow patterns that we're wanting to evaluate. Calibration, we'll go through calibrating the flow meter data. We're trying to replicate any flows that were actually collected in the field in our model. The graphic on the right is kind of we're looking to calibrate against our peak flow. The red line's what we modeled, and the green is representative of actual measured flow from that rainfall event. So we're trying to get a similar peak to make sure that the model results that we're going to be using to recommend improvements is representative of the system and that they're accurate. Some of the things that we'll adjust here, we're looking at Manning's coefficients, any roughnesses of pipes, materials, just checking some of those things, any flow factors as far as infiltration values, abstraction values from the system, making sure that our connectivity is correct. Maybe pipe networks aren't connected together at some locations, and we're getting flow moving throughout the network in an incorrect pattern. And then time to peak, this is our time of concentration in our system, so some of those values can get adjusted down or up depending on where we're off with some of the peak flows. And then just using judgment, do the results look right? Do they not look right? Just using that gut feel of what we're looking for, and just knowing what the output should actually look like. capacity evaluation, looking at system-wide, talked about that a minute ago, not just looking at one pipe run, typically wanting to do, the entire system at once. So being able to map those things out and see, where the system has capacity and issues and restriction, looking at hydraulic grade line, where's the restriction components in the 1D network, where are we spilling out, and then we can utilize this information to prioritize, where we want to start and where are we going to get the most bang for our buck to upsize our sewers and alleviate some of those capacity restrictions. And just an example of some of mapping capabilities that we can do with some of these softwares. This is out of XP Slim. Just a 1D net, or a plan view of a 1D sewer network. Running flows through the model. We can create videos and things to be able to see real time what part of the storm do we get the most restriction. Where are we popping out of the ground? The color ramp shows the red structures are where we're overflowing into the street and popping out of the system, a sanitary sewer overflow. And what we can also see is where the system is surcharged and try to just backtrack some of these capacity issues as we go through some of the processes. So, and that's it on my piece. I'll let Shane jump in here and share his screen. He's going to talk about the I&I reduction strategies associated with I&I flow in a sewer system. So Shane, if you want to, let's see. Oh, there you go. I think you have until 11, Shane. Hopefully I didn't.
Shane, I can see your slides, but I can't hear you.
About 3 cases of beer, but a little homeless looking. This is our support so it doesn't break when we have our beer shelf here and lean on it. You're almost like fuel time here.
Right. Can you hear me okay now?
Now we have you. Thank you.
There we go. A little technical difficulties here. Well, great to be with you all today. Thanks to ISG for putting this event on. It's been some great information so far, and hopefully I can add to it. We've got some different things we're going to touch on the collection system maintenance side, different approaches that we can look at to try to maintain and stay in front of the curve on this I&I issue that we all deal with. So to start out with here, just why we're doing these maintenance activities, why it's a big deal. We've got a huge capital investment in our infrastructure. Although a lot of these sewers may be 100+ years old, a lot of them are still functional and still serve the communities well. We want to prevent SSOs, keep our streams clean, and keep everybody's basements dry. I guess one of the biggest things there is, saving time and money by, being proactive on the maintenance and I&I reduction side of things. Looking at some possible contributors here, some of these are pretty obvious: broken pipes, roots, water main leaks. Excuse me. But some of the Okay, having some technical difficulties here. Can everybody hear me okay still?
Yep, we have you loud and clear.
Yep.
Perfect. You know, new construction is one thing that we see quite a bit of, you know, issues with. Not a lot of, you know, people realize, you know, the difficulties that, you know, contractors can run into during installation. It seems like most communities are now requiring CCTV inspection for new construction, which is great. You know, even though you've got a lot of great contractors out there, there can still be issues that these guys run into day to day. So getting a good eye and making sure that new construction is installed properly is going to be a big help. Storm sewer issues, you know, capacity issues on the storm sewer side can cross over right into the sanitary sewer. You know, if the water is not, you know, getting out of town and, you know, getting away from, you know, these other sewers, it can definitely cause some additional issues. Cross bores, definitely more and more of these cross bores are showing up every day in these collection systems with the amount of utilities being bored and you know, these projects going on. They pop up more and more. NASCO estimates that 1 in every 26 sanitary sewer laterals has crossbore issues, whether it's a direct hit or structural damage caused by crossbores, which you know, obviously is going to affect your I&I and you know, have some risk for homeowners and utility operators when they go to clear blockages and things of that nature. Broken pipes, you know, we've got to find those things before they collapse and cause even bigger issues on the, you know, I&I side and, you know, the safety side. Let's see, some typical maintenance program activities, you know, just to kind of look at the I&I reduction side as a whole. You know, I recommend having some sort of a maintenance program in place. You know, it's best to have it written down and, you know, documented, and you know, that way you can kind of show the councils and, you know, the people in the community what you're doing and how you're addressing the issues on the maintenance side there. You know, getting on the proactive side and finding these things before they turn into an emergency is going to be, you know, very cost effective, you know, compared to an emergency situation. You know, obviously cleaning sections of town each year. A lot of insurance companies will give you some breaks, and you'll decrease your liability. You know, if there is a backup in somebody's basement, you're going to be able to pass that cost on to the homeowner if you are actually maintaining your system. You know, more frequent cleaning in areas where you've got roots and grease and, you know, other issues. Cleaning those lift stations and making sure they're going to operate properly. Definitely, you know, getting a camera in those lines and trying to identify where the problem spots are and try to address them before they get worse. Little template here that the EPA put out. This is the 2009 version, but it's a really great resource. You know, if you guys want to start a written maintenance program, it's kind of set up to where you can, you know, enter the information specific to your community, and you know, it's just a PDF document that you can edit and kind of evolve as your program evolves throughout the years. Excuse me. Some things to look for. You know, obviously sinkholes. You know, SSOs. You know, leaves in a sanitary sewer, grass clippings. You know, all those little things that, you know, the operators on a day-to-day basis can see while, you know, working in the town. You know, all those little you know, little things that you see are leads that can really help point the direction of the maintenance program, towards the bigger problems that can be out there. So the day-to-day operators that are out in the system, document those things and write them down. If you smell, septic coming out of a storm sewer intake, it may be rotten leaves, it may be a cross connection, but those little things that you guys can see when you're out there in the system can really make a huge impact on the overall success of I&I reduction projects and maintenance projects. A little bit on the process of sewer failure here. You've got a stage 1 on top there. You've got just a separated joint or a minor crack. You get a heavy rainfall event or a blockage downstream that creates an SSO, or increases the pressure inside that pipe, and it slowly washes the soil and the bedding away from the outside of the pipe. And as that process continues, that defect is going to get worse as that soil is eroded away and washed through the joints in the pipe. And you can go from a stage 1 minor defect to stage 2 fairly quickly. If there's constant surcharging, heavy rainfall events, and take you to the stage 3 pretty quick as well. Some things to keep in mind with this process is, if you are wanting to utilize trenchless technologies to repair your pipes and maintain them, you get to a stage 3, more than likely you're going to be in a situation where you're going to have to open cut and replace that pipe. There's not many technologies that can address an issue once you get to that point. You may be looking at pipe bursting or something of that nature, but as far as the CITP approach, fold and form, those products are not going to work very well in these situations, or you're going to have added costs and have to be required to get a finite element analysis to structurally design that liner to work in that situation, which is added cost that that you can avoid by catching these problems before they get that bad. A little bit on crossbore prevention and detection. So NASCO last year, the crossbore committee released a crossbore prevention and detection specification that outlines the process from start to finish on how utility owners can prevent their sewers from being destroyed, protect their residents from potential backups due to these crossbores. Back to we've got 100-year-old sewers in the ground that are still working great, in some cases, and the value of those assets is huge. And so you've got these all these new assets being installed, but you're in a lot of cases destroying some of your existing assets, and trying to stay on top of that and prevent those problems, the added I&I, the overall destruction of the sewers, in these crossbore situations, and the safety risk to utility jet truck operators, running a mechanical cutter down a pipe to try to remove what they think is a root mass, or what may be a root mass, but in the center of that root mass there's a gas line. So a lot of risk associated with maintaining sewers that may have crossbores. So getting in on the front end, getting some sort of a program in place or a strategy in place to help prevent these issues is going to definitely help in the overall grand scheme of things. When an operator gets a one call, there's a utility company that's going to be in town doing some boring. They get a one call, and these sewers don't have the tracer wires, so they go pop the sanitary main and say, hey, it's 12 foot deep here. So I'm thinking you should be okay, in your 4 to 5 foot zone for your bore. Well, some of these houses may not have a basement. There may be some different situations where, kind of guessing on that depth and the location of the sewer mains and the laterals can really cost you a lot in the long run. So locating these laterals and the mains with a sewer camera is going to be your best bet. So this is a locate card. This was actually from the city of Washington a few weeks back. We work with Q3 Contracting and Alliant Energy on cross-bore prevention for all the gas projects that they have going on. And this is an example of the map that is created for each home that identifies the location of the sanitary sewer, the location of the lateral, both the gas and the sanitary. It gives the depth and kind of shows just gives you an idea of how everything's laid out. And having these locate cards for the future, being able to reference back to this, say if you've got a new house being built or any new construction going on, this is going to be definitely a valuable piece of information in the future. Doing this on the front end of projects, if you've got a boring project coming up in a portion of town next year, trying to get in front of it and maybe go through and launch all those laterals, locate everything, get the depth, verify the condition at that time. Whether you come back and you do a post inspection after the boring is completed, that's recommended by NASCO, but at least on the front end, if you get those depths and the location and verify the condition, you've got that information to take. If you do have issues in the future, you can kind of put the liability on the contractor there and make sure that the homeowner is not paying for it and the city's not paying for it. We recommend using NASCO, PACP, LACP coding. It's pretty much a standard throughout the country. Just kind of helps everybody understand all the defects, coding, and what it means. Up in St. Paul, Minnesota, a few years back, this would be a worst case scenario. A sewer lateral was bored through, and the contractor assumed it was roots, and he ran a root cutter down the line and caused a gas leak, and it blew up the house. If I remember correctly, I think a couple people were killed in that accident. And worst case scenario there, definitely do not want to have any issues like that. So some cross-bore types, you're looking at a gas lateral, gas mains, fiber optic, electric, just about anything that can be bored. The higher risk are going to be the gas mains and laterals. But at the end of the day, each and every one of those potential cross-bores is a definite possible contributor to your I&I problem, and again, destroying your existing assets that are very valuable. Little reference there to the NASCO cross-bore prevention and detection specification guideline. You can get that at nasco.com. Some really great people are on that committee that have some good experience in implementing these programs. Jerry Weimer, he's with this previously with the city of Dayton, Ohio, if I remember correctly. Did a great job of putting this program together there, and he's brought that experience over to NASCO and the Cross-Board Committee, and it's a great resource. Touch on some smoke testing here. Smoke testing is used quite a bit in the industry for, identifying cross connections, infiltration, different things in this collection systems. But I've seen over the years that, there's a lot of, different approaches when it comes to smoke testing. We started out just kind of doing the normal, let's smoke 4, 5, 6 blocks at a time and walk in front and behind of all the houses and look for issues. But thinking outside the box on the, especially the smoke testing side of things, because you just don't know what these, contractors did 100 years ago or 50 or 10 years ago when they installed new infrastructure, and they ran into a pipe and they made the assumption that it was a storm or a sanitary sewer and tied it into whichever line they thought it should be tied to. So you may have a situation where there's a old county tile that runs diagonally across town, and at one point near your smoke test zone there was a let's say there was a cross bore. That bore path, at one point it hit that old field tile. Let's say 5 feet later it hit a sanitary lateral. There's a new cross connection created by that cross bore, but in your normal smoke test zone, you're gonna say, let's say 3 blocks, you're gonna walk in front and behind of all those houses and kind of give it a good look, maybe spend 15 to 20 minutes and move on to the next set. Well, back to thinking outside the box, let's put somebody in a pickup truck and drive get creative, let's say a 3, 4, 5, 6, 7 block radius, and look back in the alleys and kind of look around, for different areas where this smoke could be coming out. Let's say you get 5 blocks away and you get back in the alley and you see some smoke, and there's an old old county tile intake there that's got a flower pot on top of it, covering it up, and there's some smoke coming out of it. It may have taken 30 to 45 minutes for that smoke to reach that point, to work through all the the soils and the roots that may be in these pipes, but it takes some time getting through those defects and the roots, but being able to find those hard to reach, hard to imagine issues throughout the system is really going to pay dividends in the long run. So ultimately, taking your time, instead of a 15-20 minute test, let's try and push it out to 30 to 45 minutes. Let's think outside the box, get somebody in a pickup truck driving around. Let's cut those sets down. Instead of doing 4 to 6 blocks, let's cut it down to 2 to 3 blocks, making sure that we install plugs to isolate that test zone to bring the head pressure up in that area. That's going to be make a huge impact on the success of a smoke testing project, is getting those plugs in there and giving that smoke time to reach those defects. Once you, let's say you find a cross connection, that's a big thing that, we see throughout the years is, a community smoke tested the town, let's say 10 years ago, and they've got a booklet of all these issues that they found. And, there's cross connections that they identified in that project. Well, they never did anything with those because they didn't know where it was connected and how it was connected to the system. So making sure that you identify how it's connected and how it can be fixed is, a huge step in this process. So whether you dye test, the sewer, the storm sewer, or you back smoke that storm sewer while you've got a camera in the sanitary, and you can identify where it's coming in, how it's connected. You can flip that around, put the camera in the storm sewer, and then re-smoke the sanitary or dye test the sanitary. Most of the time with the dye testing, you've got to, plug it off and get that water level up to, get some head pressure in there to force that dyed water through the soil and through the defects. So typically you're gonna have better luck, quicker process with the back smoking to pinpoint those cross connections and some of those issues. From there, you can determine whether it's an issue that can be addressed by trenchless technologies or if it's an easy dig. Just knowing how to fix it is a big part of the equation there. Another reference there to NASCO Performance Specification Guideline for smoke testing. Great resource as well. Highly recommend looking at both of those. Now we're going to talk a little bit about the rehabilitation side on these I&I reduction projects. 10, 15 years ago, most communities were under the impression that, if they line their entire system, CIPP, manhole to manhole, the town, they're going to eliminate their I&I problems. Well, we've kind of learned through the years that that's not the case. Some towns have seen their I&I problems get worse. That may due to how much exfiltration was happening before the lining project is one point, and a second would be, if you didn't address the manholes and the connections to the houses, with this project, you're pretty much just moving that water around. So the mainline steam cure polyfelt lining systems, they shrink a little bit, and there's an annulus between the liner and the hose pipe where water and roots can track through, and the water will come in at the manhole if they're not using end seals, which seal that gap off at the manhole and prevent the water from coming in there. And the water will come in at the connections if those connections aren't being grouted or being lined with some sort of a connection liner to seal that connection off. So, kind of taking a step back and, let's say we've got a 10,000 feet lining project, and your budget, doesn't allow for, the manholes or the connections or anything like that in that project. Well, if you want to have a higher rate of infiltration reduction, I would recommend, let's say instead of lining 10,000 feet, let's line 5,000 feet, and let's address, rehabilitate, seal up the manholes in that basin that we're working in and the connections to the houses, the lateral connections. And you're going to see, from a base reduction with a standard CIPP project without addressing those issues, say an average of 30% reduction, you're going to see that increase up to 65 to 75+% reduction by going with a comprehensive approach. Just a little clip here, the lateral connection repair. This particular product goes 2 feet up the lateral using a zero shrink resin, so it seals up the entire connection. It gets a seal through the full length and full area of the repair. There are other products out there that go from the main all the way to the house if there's a need or a desire to address those in the same shot. This particular product in most cases does not require pre-grouting. A little clip here showing the infiltration at the connection after a mainline lining project where they did not address the lateral connections. Just a little clip here showing the difference between your standard polyfelt resins that they use, the steam cure resins used in manhole-to-manhole lining projects. It shows the annular gap there on top. On the bottom, you're looking at a zero shrinkage resin, which is going to be your silicates or your epoxies. Those are typically used for point repairs and connection liners. They definitely do a great job of structurally fixing issues and creating a watertight seal. A couple other advantages with the zero shrinkage resins is they have no VOCs or styrenes, so there's no risk of exposure to harsh chemicals. And the silicates in particular, they do not emulsify when water hits them. It comes in contact with the resin, like a polyurethane or a polyester resin would, or an epoxy. So you are able to stop quite a bit of water without pre-grouting with the silicates. In this case here, this was down in Norwalk, brand new construction. It was a pretty deep pipe right next to a creek, and the contractor really didn't want to dig it up. So this was a good situation to use the silicate CIPP spot repair. You've got a 50+ year design life similar to the manhole-to-manhole lining, but just a great tool in the box for some of these situations with heavy infiltration that you want a long-term solution for. Another one here with the silicates, pretty rough structural defect there in an old clay pipe. You got the point repair installed. You can see it kind of helped reshape that pipe, lifted some of those broken chunks up, and you've got a pretty good repair in there that's going to last a long time. Wrap it up there. Looks like I went a little late. Does anybody have any questions? Let's see here. Doesn't look like I have any on the messages here. So great to be here with you all, and appreciate the time. Everybody take care and stay safe.
Thanks, Shane and Brett. Next up is Tom Atkinson from the DNR field office. And so Shane, yep, there you go. Tom, it's all yours when you get your slides loaded and ready to go.
All right, does it look like they're coming up, and can you hear me?
I can hear you fine, and it looks like there it is, they're up.
All right, sounds good, we'll get rolling. So again, my name's Tom Atkinson. I work for DNR Field Office 5 in Des Moines, doing primarily wastewater inspections in the south central part of the state of Iowa. I wanted to echo what Julie said, just a big thank you for all the staff that are out there working, keeping the environment safe, keeping sewers running, keeping the water plants running through everything that we've got going on. So just a huge thank you for all the work that you're doing. Currently, DNR staff is working at home, working off-site, potentially through the end of May. So still doing work, still doing inspections, still available via email, phone calls, what have you. So you should still be able to get a hold of staff, but things are a little bit different for sure. And there may be a few delays just because people are working at home and working off-site instead of in normal office spaces. But we'll get rolling. Today we're going to cover wastewater inspections, what you can expect if the DNR shows up for your inspection, how frequently, things like that. So the main purpose of the inspections that the DNR does are to formally determine and document the compliance status of your facility. So a couple different types of facilities we're looking at. When we're talking about major wastewater facilities, those that have a design capacity greater than 1 million gallons a day, you can expect to have an inspection at least every 2 years. Sometimes those might be more frequent, but the schedule we've agreed to with EPA is at least every 2 years we'll be visiting each facility. When it comes to minor facilities, and that is essentially the group of everybody else. So whether it's a community, whether it's a mobile home park, what have you, they're all considered minors. Return frequency there for inspections is going to be 2 to 5 years. And typically that's going to be driven by what's going on at the facility, whether there's upgrades going on, whether there's compliance issues, anything like that, staff timing as well. But if you've got a good compliance record, everything goes well, that's going to be a longer return between inspections. If there's constantly compliance issues, you're going to see somebody more frequently. But typically the inspections are going to be a general technical assistance opportunity. So yes, there's a check the box that we did an inspection, there's a report to be written up, but really it's a huge technical assistance opportunity. So take advantage of that. You've got staff that are on site that have different levels of expertise, have seen a lot of different things, a lot of different facilities. So if you have questions about what's expected of you, make sure that you use that as technical assistance opportunity as well. With that said, there's a ranging variety of inspectors within the DNR, different levels of focus, different levels of experience and expertise. So not every inspection is going to be exactly the same. Different inspectors might be looking at a little bit different things based on their level of focus, what they're interested in, and their level of expertise and things. So you're going to see some variation, but overall, things are going to be very similar. So what to expect? You're going to have general introductions when somebody shows up, discussions on what's going on at the facility and records review, treatment system walkthrough, observing treatment units, things like that. Taking a look at the collection system. If you've got pump stations, dump stations, areas of bypass, things like that, we'll want to take a look at them. Having some final thoughts and summary report out, and then expect that there's going to be a written report to follow every inspection. Which, depending on the findings, might require that there be a written response from the facility. Just note that you might not always get prior notification to an inspection. A lot of times we do, especially in this current pandemic. We are notifying facilities prior to an inspection, so you should get a phone call or email to set things up. Generally, just to make sure that we've got staff there that can do the inspection with us. But that's not a required thing in normal operation. So somebody could show up at your facility on any given day and say, guess what, today's your lucky day, it's time for a DNR inspection. So if it really doesn't work, we can work around that, but just note that you're not always going to get a heads up. If you do get a heads up, feel free to clean up. It says a lot about the facility, it says a lot about your desire for the facility and how much you care. Just to pick up trash that's laying around, clean the flumes, clean things up, empty trash baskets and lift stations if you happen to be breaking the law and pumping sludge to the creek, stop it that day. Things like that. So mow the grass, clean up, take pride in the facility. All right, a little more detail on the different pieces. Discussion aspect of it. What's the purpose of the visit? There could be other reasons that the That was the other thing I meant to mention. I've been getting kicked off occasionally too.
We can hear you, but your slides are still coming up, Tom.
All right.
There you are, you're back.
All right. Yeah, I meant to say I've been kicked off a few times while I've been listening in, so hopefully that won't happen too many times. But the purpose of the visit, whether it be just a site visit, somebody who's stopping through town, or whether it's a formally scheduled inspection, just discussing on why the DNR showed up at your door this day. Logistics of the facility and what route we want to go, whether, the weather plays into it. It's raining today. We might want to sit down and do the discussion and the paperwork review first and then go look at the facility. If it's sunny right now and it's going to rain in an hour, we might want to go and walk around and tour the facility first. Just logistics like that. How are things working at the facility? Is today normal operation? Things tend to break the day that the DNR wants to show up and do an inspection. I don't know how that happens, but it happens frequently. So if there's things that are out of the ordinary, let's talk about it up front and make sure that we're aware of the situation that's going on, what we're observing today, and whether it's normal operation or not. Generally, we're going to use the previous inspection as a guide. A lot of times that's a good way to prepare, is to take your last inspection and know kind of what you're going to have coming up. But also, we've got reports that we can run out of our data systems based on the data that's submitted on monthly reports. So we can talk about compliance status and things like that in the discussion portion as well. So records that we're going to want to see, we're doing this in determining compliance with an NPDES permit. So you should have a copy of that permit. You should know where it is. You should know what it requires. A lot of places have at least the monitoring page or the limits page pinned up on a board somewhere, which is great. You've got it readily accessible. But there's a lot more in the permit than just the monitoring and the limits that are associated too. So making sure that you've got a current copy of your permit and you know what it says. And this is always a good time to break down the language in the permit and try and put it into English that people can understand. So make sure that if you've got any questions on exactly what that permit language requires of you, feel free to ask. Printed and signed discharge monitoring reports. So a lot of the facilities in the state currently email their discharge monitoring reports into the DNR, into their field office each month. If there's any anomalies on those, any violations, we're going to want to discuss those. But make sure you've got those available so we can take a look at them and verify. You've got to keep at least 3 years of those records. Most communities keep many, many years more than that. But just make sure you've got at least 3 years of those records and we can verify that you're keeping enough. And keeping your lab reports, we should be able to look at those as well. A lot of times that's very helpful. If we find an anomaly on the discharge monitoring report, we can cross-reference that with the actual report from the lab. And if it's an accurate result, make sure you question up front when you get lab results back if something's not normal, so that we can have that discussion if there's something out of the norm. Make sure you've got documentation for stuff that you wouldn't necessarily send to the lab. So if you're doing pH, dissolved oxygen, temperature, residual chlorine, or anything else on site, make sure you've got your bench sheets or your log books to note what you've got for those sample results as well. And along with that, making sure you've got calibration records for all of your meters. So pH meters, DO, flow meters, all of those things. Default for all of these for calibration is that I'm sure you've either seen or heard the DNR say that you've got to have everything calibrated based on the manufacturer's recommendation. Well, the analytical methods for some of those things, such as pH, require that they be done on a daily basis, not necessarily your flow meters, but your pH. When you're doing compliance sampling, you need to make sure that meter is calibrated the day you're doing compliance sampling, and document it. Kind of back to if you didn't write it down, it didn't happen. Make sure that you document when calibration was done. Best way to do that is let's use pH for an example. If you're using standards of 4, 7, and 10, write down that you did standard 4, this is the result you got. You did 7, this is the result you got, and so on. If that meter gives you a slope, write down what the slope was. Documenting all of that information as opposed to just a check mark that you calibrated the meter. A lot of times we'll get salesmen and operators that have bought something from the salesman say, well, my meter stores everything internally. That's great. It's nice to have, but I don't think I've seen one yet that stores 3 years worth of calibration records, and your calibration records fall under the same records retention of 3 years. So making sure that you've got all of that available if necessary. Maintenance records, things that you've done, replaced equipment, fixed equipment. Do you have an actual schedule? Do you have an O&M manual? Do you utilize that for the schedule? Is there a scheduling mechanism for preventative maintenance and routine maintenance? Keep charts, things like that, log books. A lot of operators have a big calendar on their desk. They write notes on when they did things. That still falls under the same records retention. So if you're using that calendar to document when you did things or what readings were on those days, fold those up and stick them in the file cabinet for 3 years with everything else. Sludge generation and biosolids disposal. So if you're doing land application and biosolids, you've got to have the 5-year land application plan. and make sure that that stays updated, including your fields and staff and equipment, things like that. Noting that that 5-year plan has to be updated at least every year. So it covers a period of 5 years, but it has to be reviewed annually to make sure everything's up to date for the coming year. And then you've got the report itself for application data. If you are one of those major facilities, that information gets sent into EPA, into the Iowa DNR. If you are not a major facility, but you're doing land application of biosolids, then you have to keep that information on site. So what field it went to, how it was applied, how much it was applied, and the lab data, all of that information. So all of those things fall under the 3-year records retention schedule. When we get to the treatment plant, we're going to be a walkthrough. How does the plant work? A lot of times you might feel like the inspector's asking a lot of stupid questions, like, why don't you know this? You've seen enough facilities. Why don't you understand it? Part of that may be that they haven't seen that many facilities and they don't understand it. The other aspect of it is you're being asked questions to be able to demonstrate that you understand it. So the questions might seem like they're kind of silly or kind of basic, but it's so that we know that you have an understanding of how your facility works. So typically we're going to start at the beginning, start at the headworks, and just walk through treatment unit by treatment unit from the front to the end of the plant. And how's it normally operated? If things aren't normal operation, discussing why, but also discussing the different potential for operational modes. So whether you've got different monitoring, if you've got different flow schemes, if you're running high flow versus low flow, seasonal differences. A lot of plants will shut down treatment units during low flow or during seasons of low flow and bring things back on during high flow. Or when different limits are in effect. A lot of times disinfection will shut down during the winter months. So are we in the winter? Are we in the summer? How do you shut down and start things back up? Moving to a visual inspection of each treatment unit. Again, discussing what those operational conditions are. If you're seeing bulking of sludge, is this something you typically see? Did it start yesterday? Has it been going on for a month? If everything looks great, great. And functional, what's in operation, what's out of operation at this point, and again, are these normal conditions or not? Jump to lagoons a little bit. We do have quite a few lagoons in the state and different aspects that go with them that might not go with some other types of facilities, but fencing, locking, making sure the gates are locked, signs all the way around the facility so people know it's not their local fishing pond, but it's their wastewater lagoon. Lots of vegetation to maintain on a lot of these, mowing for easy access, also so you can see, so you can observe the integrity of the berms. A lot of people ask questions about how long or how short does the grass need to be. It doesn't necessarily need to look like the fairway on the golf course, but I typically say it needs to be 6 to 12 inches or less, so you can see what's there. If you see damage, if you have holes in it, you have seeps, things like that. You want to be able to identify and see that. Woody vegetation is a no-no. Make sure you get that off the berms. And if there's any excessive aquatic vegetation within the lagoons, there can be some maintenance of that as well. Water level, can you measure it? We typically expect it to be between always maintaining 2 feet of water in the lagoon to keep that clay liner wet and to keep enough there, and to make sure there's at least 2 feet of freeboard at the top. So if you do get a big rain event, you're not in danger of going over or causing damage to the berm. So you've got that operating level between 2 feet in the bottom and 2 feet at top. But can you actually measure that amount? Accuracy of measurement only has to be within 6 inches. So we're not looking for a real finite determination of measurement, but some type of gauge that you can measure how much water is in that lagoon cell. Conditions of valves and control structures, making sure those control structures are locked or secured so people can't get into them. Yes, oddly enough, people have gone out and drained the lagoons. Why, I'm not real sure, and how they understand what's there is always a question. But locking that makes a big difference, so you have control over it. Conditions of those valves, especially interconnecting valves, things like that, making sure that they're functional so that you can use them when you need them. If you've got aerated lagoons, we want to make sure that there's an even aeration pattern. Especially if you've got aeration lines and submerged aeration, that you don't have big leaks in the air lines or dead spots in the cell. So you've got adequate aeration going on. So this is a pretty good looking lagoon cell. Grass is mowed pretty nice. Oddly enough, I was actually there this day because they do have very excessive vegetation in the lagoon. It's hard to see here, but it was significant enough. It was clogging up the surface aerators. So, but it made a pretty good picture, at least from this view. So riprap around the interior looks good. Mowing around it looks good, and water levels well maintained. Something to note here with baffle curtains, we have a lot of facilities with baffle curtains. This one looks good, but a lot of times they do end up submerged. If you end up with a section of it that's submerged, you're in danger of short circuiting, and it's not doing what it's intended to. So it either needs to be tightened and lifted, or floats repaired, or replaced to make sure that it's doing what it's supposed to. This one, not so much. Vegetation control is a big deal. I always tell people that if I had to go out in the morning, especially on a day like today, and walk around in wet grass that got wet all the way up to my waist, I'm probably not a very happy guy. So it doesn't really bode well for doing an inspection when I'm uncomfortable either. So maintaining your system can have other effects as well. But maintaining the vegetation around a lagoon cell is critically important. This one, tree in the berm there in the foreground, it's difficult to see with the snow cover there, but way out in the middle, you can just see the top of a post that shows, even with that snow, there's about 6 inches of freeboard. So this one was in quite danger of going over the top. This one was kind of my favorite. I walked out here in the snow and found out how people were getting out there. You had to take a snowmobile out to the lagoon, but the snowmobile trail actually had signs right up to the bank, and it was the burned corners of the lagoon were the burned corners of the snowmobile trail. So I wouldn't necessarily want to be the one responsible in holding the liability if somebody rolled a sled into the lagoon. There's a reason that there's fencing and controlled access to wastewater sites. So making sure that you're not allowing access to the site, especially something as significant as promoting access to the site with a snowmobile trail or other trails. So this was an aerated lagoon. This one you can notice that the car mirrors in the bottom right corner. This was not an announced inspection. This was actually just driving by on the highway, and I thought this was an aerated lagoon. There doesn't seem to be anything on. So all of the aeration was off in this system. Giving them the benefit of the doubt, there are systems that cycle air on and off because it's not necessary to have the air on 100% all the time. And that happened to be what was going on here. It was just a timing where the air was off. If it's off for 10 minutes, an hour, or something like that, it was off for a while. But just making sure that the aeration systems are functioning as they're supposed to. Valves, making sure that they don't leak. Lots of times you end up finding valves that leak or are completely rusted shut and inoperable. So making sure that they function when you need them. They're there for a reason, so make sure they function correctly. Your outfall. Occasionally observe your outfall. This is one where in the middle of the winter, this one's not supposed to be discharging. It's not discharging a lot, but it is discharging some. So it's just a simple matter of after they discharged in the fall, the valve, controlled discharge lagoon, the effluent valve didn't seat quite right, so all winter long they had a small discharge after the lagoons filled back up. So occasionally observe the outfall, because this would have been an easy fix to just go and open and close that valve again and make sure it seats correctly and stop that discharge. Some things that are applicable to all facilities. Flow measurement, making sure that we've got it at an accurate and a safe and appropriate location. So talking about accurate and appropriate locations, for raw waste, we want to make sure that flow is being sampled with everything that's coming to the facility. So before things are split off to flow equalization basins or other processes, we want to make sure it's everything that's coming from the community to be treated. So that's what we're looking for a raw waste flow. And from an effluent flow, we're looking at what's going out the effluent pipe. There's different ways to set up meters throughout the system based on what you have or what. and I'll resume momentarily. All right, making sure that we've got those flows at the accurate locations. The same thing goes for sampling locations and making sure that when we're talking about getting a representative sample of our influent or effluent or whatever point is required, that sample is representative of the waste stream. Composite samples versus grab samples is the same way. One thing in the representative of the waste stream discussion and the intent of the sampling, an example of that would be dissolved oxygen at the effluent. We're starting to get a lot of permits with DO sampling and DO limits on the effluent. And if your typical sample location is on the backside of your discharge weir and you've got a big pool there, but then it goes over the weir, falls 10 feet, splashes around, gets reaerated right before discharge. If you sample on the backside of it and you're getting 3 or 4 milligrams per liter of DO, that's a violation of a limit of 5. But it may not be representative of what your facility is actually discharging. If you sample it on the other side of the weir after it's splashed around and been reaerated, which is actually what's being discharged, and you're at 7 or 8 or 9 milligrams per liter, you'd be in compliance. So just making sure that you sample and demonstrate what is appropriate and what's being representative of what's required. Same thing on the influent side of things. If you've got sampling on the front side of the plant, but it sits in a stagnant pool in the corner of your influent channel, that might show worse sampling than what's actually going to your system. So making sure that it's benefiting you and also representative of the waste stream. Composite sampling, typically influent sampling is going to be composite. Continuous discharge facilities, effluent sampling is going to be composite, except for except for lagoon system. So if you've got a lagoon system, aerated lagoon or controlled discharge, you're going to be looking at grab sampling for the effluent. That changes a little bit when you start adding technologies to your aerated lagoon system. So if you're looking at adding a Sager system or something like that after your lagoon, you're still going to be looking at composite sampling of the effluent because you're no longer just a lagoon system. But grab sampling, that's going to be the parameters that have to be grab samples, pH, oil and grease, temperature, TRC, cyanides. Those things have to be grab samples, so making sure that they're done correctly. We move to lift stations, pumps, motors, other equipment, things like that, just making sure that it's being maintained. So that note there that proper maintenance saves future headaches. Stuff typically doesn't break on a sunny Tuesday morning at 9 o'clock when you've got all day to fix stuff. It's usually going to be, Thanksgiving night or Friday afternoon right before you want to go home. It seems to be when things break. So a little bit of maintenance can go a long ways to prevent those future headaches. And if you find something that looks broken, sounds broken, or smells broken, please fix it. As Shane mentioned, a lot of times you end up doing work in the collection system and identifying problems, but that doesn't get taken to the next step of being fixed. If you don't fix it, you haven't really done anything. So making sure that things get fixed when they get identified. And honestly, failure to properly operate and maintain a facility is the most commonly cited violation. Whether it's EPA doing an inspection and citing violations or DNR doing it, failure to properly operate and maintain is the most commonly cited violation. So making sure that you're putting effort into maintenance is important. A little bit on the accuracy of flow measurement and some examples. Just an easy one, we see a lot of 90-degree V-notch weirs. What you're doing is you're measuring the head through that weir and comparing it to a chart to determine what your flow is. It's happened more than once that somebody's got the wrong chart. So you might be doing all the measurements correctly, you might be doing the math correctly, but the factors that you're putting into it aren't correct. So making sure that you've got the correct numbers and everything that goes into that. The partial flume on the right, flumes need a straight shot for flow to go through it unrestricted so you can measure flow accurately. So under normal conditions, this might be just fine, but if you end up with those conditions where you end up with a lot of I&I and high flows, and flows coming from left to right in that picture, if it gets bound going around that 90-degree corner and starts to back up, now you're getting erroneous flows because that flow is backed up into where the meter is. So making sure that you understand the equipment and the situation that's going on, so we're getting accurate flow measurement. Safe flow measurement's another aspect of it. So these are a couple of pretty deep pits. The one on the left is kind of hard to see, but there's a pipe running down behind that ladder. And the operator can stand up above this pit and stick a pole down that pipe. And at the bottom of the pipe it opens at the bottom, but there's a plate at the bottom that's at the same elevation as the notch in that weir that they measure from. So you can stick a pipe down there, and the wet spot on that pipe will tell them how much water is flowing over that weir, and you can use that to calculate its flow. Similarly, on the right side, a little jumbled in there with valves, so that can make things a little more difficult for accuracy, but there's a gauge on the wall that you can stand above it, and you can read how much water is flowing over the weir based on that gauge. So just some things where you wouldn't have to enter a pit to be able to measure your flow. Similarly, bar screens, making sure they're raked frequently enough, whether they be manual or automatic bar screens, different screening, make sure it's raked and cleaned frequently enough to prevent backups, because as your flow meter is reading the level of water in the system, if it backs up due to blockages, you're getting erroneous flow readings. In regards to bar screens, another very common violation that's noted is stabilizing those screenings with hydrated lime before they go to the landfill. That word hydrated is critical. Lots of facilities will use sweet barn lime or ag lime, things like that. This requirement actually comes from our solid waste regulations, not our wastewater regulations. But solid waste regulations require that stuff to be stabilized by reaching a pH of 12. So if you're not using hydrated lime or something like that, you won't reach a pH of 12. Barn lime or ag lime is only going to get you up to about a pH of 8 or so. So it's not sufficient for that stabilization. Moving to the collection system and lift stations. We're going to look visually at the lift stations, want to get in and look at the wet wells if we can. How often are you visiting the lift station? What maintenance is done? Is it cleaned out? Trash baskets emptied? And again, that trash basket material, making sure it's stabilized with lime to get to that pH of 12. Are alarms functional? Do you have backup power? Do generators function? Are they tested, exercised? If you've got a big enough generator that requires registration or permitting from the Air Quality Bureau, has that been taken care of? Looking at those things from a lift station perspective. If you've got bypasses, common places of bypasses, we might want to take a look at those as well. From the I&I identification and reduction program aspect of it, just in general, this falls under the same requirement for proper operation and maintenance of your facility as the treatment plant does. So the collection system is part of your facility, and those O&M requirements apply there as well. They might be out of sight, out of mind most of the time, but there's an expectation for maintenance and operation of them. So what's being done, whether that be smoke testing, televising, is there routine cleaning? Lots of questions on cleaning. What's the appropriate frequency for a community to clean their system? A lot of times we'll see it get sectioned off into 4 or 5 sections of town and hit one section a year. So every 4 or 5 years, the whole system's been cleaned. Adding the areas of problem areas where you know you need to do more frequent cleaning, whether that be annually or more frequent. I did make a comment to somebody the other day that if you need to clean an area of your sewer more frequently than every 3 to 6 months, then you probably ought to look at addressing the problem as opposed to increasing the cleaning frequency. But just keeping that in mind. Repairs, are there things that are broken? Are there issues that are found? Make sure those repairs get done. Sump pump ordinances, fog ordinances for fats, oil, and greases, things like that. Any stormwater connections, whatever you find, make sure that you are addressing things that are significant contributors to your I&I, or especially if they're structural deficiencies. Paying attention to pumps and motors. A lot of times we'll have hour meters on them. If one pump's running much more frequently than the other, ask yourself why, and then investigate it. Are we looking at issues with impeller wear, pump cavitation, poor placement, rubber duckies? What is it that's causing that one to not function the way it should? Especially if you're using hour meters and pump run times to determine flows, make sure that there's occasional drawdown tests to determine the pumping rate. So you know the capacity of your wet well or a portion of the wet well. How long does it take to pump it down? Do both pumps run comparably? How do they run if they're both on? And if you do this on a routine basis, how do those results compare to the previous test? If you are using this for flow determination, raw waste flows specifically, but any flows, if you're using, a lot of times we'll see a spreadsheet that people have put together and they can just put in pump run times and it'll calculate the flows for them. The one thing that's in there is those pumping rates. So if you do a drawdown test or you evaluate the pump rates, make sure if it changed, you change your spreadsheet so you accurately account for that in your flows. If you've got any squealing, grinding, smoking, banging, anything like that, those are typically problems. So make sure that you are addressing the issues that are going on. Although I heard that it's been replaced, but I know of one community that the best running pump is the one that sat there and squealed for years and years and years and would never quit. I did hear that it's been finally replaced, but it was the one that seemed to run the best. Jumping a little bit different topic, part of the collection system are your users in the collection system. So significant industrial users, when we're talking about significant industrial users, we're talking about those that might be greater than 25,000 gallons a day discharged to your system. Those that might account for 5% of your hydraulic or your organic load, so high strength waste, or for a smaller community, if it's at a 5% of that flow to the facility might be the contributing factor. Anybody that discharges a toxic pollutant, which is identified in the Clean Water Act, or categorical industrial users as designated by EPA. Those are going to be your metal finishing facilities, pharmaceutical facilities, plastics manufacturers, battery manufacturers, things like that. They've developed categories of regulations for those different industries. There's also a catch-all category of determined to have or potentially have a significant impact on the POTW. So that could be based on the strength of the waste, the components of the waste, somebody that lies about what they discharge, a concern by the city. Lots of different reasons could trip into that last category. So the question is, do you have any significant industrial users? If it's based on high flow or organic loadings, talking to the water plant, if it's a different operator than you, talking to the water staff, do you have any high volume water users? Are there any food or feed additive companies? Lockers. This is actually something that you may be seeing. If you got a locker in town, you may be seeing some communication from the DNR in the very near future. The governor mentioned Pass the Pork, I think is the initiative, which is trying to get some hogs that don't have an outlet to a packing plant to some local lockers to get them processed to get that meat to the food banks in the state. So there's some communication coming out that if this happens, some of these lockers are talking about expanding operation, expanding hours, things like that. You may have not seen issues in the past, but if they start running a lot more hogs through the operation, you may see some changes to what they actually discharge. So if you get something, I think it's supposed to come out as an email, but if you have a locker in town, you might be seeing some communication in the next week or two. Categorical industrial users, I mentioned metal finishing facilities. So if you've got a local metal fab shop or somebody in town that does powder coating or painting, the steps that they do to the metal to prepare it to hold the paint typically are what throw them into the category for metal finishers. Historically, we've got a lot of small shops that do work for John Deere and some of the bigger corporations. If your shop is doing parts for them, they may be doing metal finishing operations as well. Chemical formulating, packaging. Sometimes we have co-ops that actually do chemical manufacturing or repackaging of things. So there are some regulations that could apply there. Most co-ops do not fall under those regulations, but a few of the larger ones, or the ones that are doing those operations, would. What about that shop over there, that building over there that doesn't have any markings on it, but you know they do the pharmaceutical stuff? A lot of the pharmaceutical industry and things are very secretive, and there's not a lot of information, and some of it is way over my head anyway. But there are pharmaceutical standards. If they're making active ingredients for pharmaceuticals, there are standards that would apply to them. If they're making nutritional products, things like that, that are not marketed as pharmaceuticals, or they're doing things that go into pharmaceuticals, but they don't actually make the active ingredients, then they may not be subject to those standards. Don't worry, in this group, you don't have to make that decision yourself. So call your field office, ask. You can call into the NPDS section. They've got a couple people now working in that group with industrial users and pretreatment program. And if it's over all of our heads, we always have the option to take it to EPA to help us make the determination of whether a facility is actually a categorical industrial user or not. The other ones that fall into the Okay, those that fall under potential impact of the POTW. Landfill leachate. This is one where not only can the landfill leachate have a potential impact on the treatment plant, but our solid waste rules, require landfills to have a permit on or a plan to dispose of their leachate. That can be at a POTW, at their own discharge, what have you. So a lot of times we have treatment agreements with landfill leachate from the standpoint of disposal recommendations and permitting from the solid waste side of things. Potential for slug discharge is exactly that. Does a facility have a non-routine discharge that they could slug the treatment plant with and cause issues? pH issues, either high or low side of things. And Julie talked a little bit about chloride and chloride standards, the high salt loadings, dairy facilities, ice cream, milks, cured meat products. Bacon's fantastic, but it has a lot of salt that goes into it. Water treatment residuals also, a lot of those could have chlorides in them or high salt contents that could have potential impacts on the treatment plant. In general, in the water treatment residual side of things, if it's the city's treatment plant discharging to the city's wastewater treatment plant, we do not require the treatment agreement aspect of it. And that's in the oversight realm. So significant industrial users are required to have a treatment agreement with the city. So that's signed by both parties, identifying who's responsible for both parties, and identifies the limits that go into what that facility does and what the limits are for the discharge from the facility to the city. That gets incorporated into the city's NPDS permit and includes the limits and then sets the monitoring frequencies for the industrial user. So there's an expectation for the city to make sure that the industry complies with that treatment agreement. So that might mean that you've got to visit the facility regularly, develop some kind of rapport with them to help them help you stay in compliance. How do we make sure that they're in compliance so that it's not impacting your treatment plant or impacting the environment? So when we do an inspection of your facility, we are likely going to visit one or multiple significant industrial users as well. You're always encouraged to go along with those. Usually that tells me whether you have the ability to go there, whether you've got a rapport with them. But yeah, making sure that you have the ability to go to that facility as well. If the DNR reviews compliance, we typically do that on about every 6-month basis. And if we look at the industrial user and they have a lot of violations, enforcement action is going to depend on what's going on. So enforcement action for the industry depends on the severity of their violations. If they have a lot of repeated violations or they have violations that are way over their limits, there's going to be enforcement action against the industry. But with this also, there's the potential for enforcement action against the treatment plant. So if the treatment plant is making no effort to make sure that the industry complies with those treatment agreement limits, then there's a potential for enforcement action, notice of violation against the treatment plant for not implementing that treatment agreement. It's pretty rare, but that's a possibility. So something that's not totally regulatory, but our inspections are typically going to look at safety concerns as well. So confined space entry is one. We do find a lot of confined spaces at treatment facilities. A lot of sewers are deep, manholes are deep, wet wells are deep. So confined space entry is a piece that can be discussed, like I said, not from a regulatory standpoint, but just from a standpoint of safety concern. Noxious gases in some of those places, or currently big topic of discussion is infectious diseases from wastewater. So what's the necessary protections? Currently with this virus, we're not looking at anything more significant from a PPE standpoint or protection than anything else. So if you take a bath in the wastewater, you need to clean yourself off because there's a lot of things that are in there that could potentially get you sick. Slips, trips, falls, especially where around water, things can get slippery when they're wet. A lot of hoses, piping, things like that, making sure that we've got a clear space that's safe to work. Electrical and mechanical dangers, whether that be lockout, tagout, whether that be guards on equipment, whether that be open panels right next to where you have to stand and work, just making sure that you're keeping yourself safe. And there's always critters to deal with too. So caution near your water. If you've got to go out on the water, maintaining your aeration system. If you've got railings around aeration basins and things like that, making sure they're maintained so that you have a safe working environment. Critters, obviously these aren't from Iowa, but wasps, these nice sunny days we've had prior to today, wasps are definitely coming out and they love to be in control panels and things like that, so pay attention. Nick, I saw you're online. I'm not sure if you've seen any of your rattlesnakes down in Winterset yet, but when it starts to get sunny and warmed up here, I wouldn't be surprised to see some snakes that are across the drive or in the parking lot. So there are snakes, there are venomous snakes in the state, and they can be around our facilities. Haven't seen any gators in the sewers in Iowa yet, but people flush all kinds of things. And I don't have the picture in here, and it doesn't really fall under critters, but safety and pump stations, I incidentally took a picture of a pump one day and didn't notice it until I was actually trying to put it into my report, and there was hypodermic needles sitting right on top of the pump. So people flush all kinds of things. You never know what's going to be there. Just make sure that you are keeping yourself safe. Sampling. DNR used to do a lot more sampling during inspections, but that doesn't necessarily mean we're not going to collect samples when we come out to do an inspection, especially if there are some water quality issues suspected that we observe or we find a discharge. I mentioned pumping sludge to the creek earlier. If we find that when we come to do an inspection, we're going to collect samples because it's likely going to become an enforcement case. The other aspect of sampling that's more common currently is compliance sampling inspections. So this is when we get the state hygienic lab to come with us. They set up composite samplers, influent, effluent. They might do it at significant industrial users, different places throughout the plant. If there's information that you would like when we do a compliance sampling inspection, we can collect a lot of different samples for a lot of different things. So that's something we could add sampling or add a location as we're doing the inspection too. But that's a common way that we're doing sampling during our inspections. One other thing I realized I didn't put a slide in here for is operator certification. Obviously, you're taking the time today to maintain your CEUs and your certification, but just a discussion on the staff that's there, whether you've got properly certified operators for the operator in charge and also for shift operators. So if you've got people that are working, weekend shifts or the certified operator's not always there, making sure that they've got the proper levels of certification. So jumping to final thoughts, there's going to be a report out of some sort at the end of the inspection. Attaboys for things that you're doing well. There's always recommendations for things that can be improved and what to expect in the report. When you get the report, it shouldn't really be a surprise of what comes out. So you should have that information as the inspector leaves the site of what you can expect. Another big thing is there anything that we can include in the report to help you get what you need? Sometimes, council or management level staff doesn't want to listen to you if you continue to ask them for things. But if there's something that we can lend support to, whether that be to do additional work in the collection system, whether that be to get a piece of equipment to help you do your job better, I can't necessarily argue to get you a raise, but if there's something that needs to be done, you say it needs to be done, and you just can't get the support to get it done, we can put those as recommendations in our report, and sometimes that holds a little bit more weight. So don't be afraid to ask. We can always either put a recommendation in, or if it's out of our wheelhouse, we'll tell you we can't do that, but we can lend support what we can. And then thank you for your time and cooperation. So as I said, each inspection is going to come up with a report that comes out after it, documenting the inspection, what was seen, sample results if samples were taken, a compliance status, so there'll be a determination of whether you're in compliance or not, and then requirements and recommendations. So if there are any violations whatsoever that occurred during the period of review, there's going to be a letter of non-compliance. So any violation, anything, that inspection report will come out, the cover letter will be a letter of non-compliance. If they are significant violations for repeated violations, very high level or something very bad, there's some definitions for significant, but it'll be a notice of violation. So there's those two types of letters that you'll typically see. If that's the case, there's going to be a request for a response, generally going to be a 30-day time frame to respond. So noting those deficiencies and what you can do to correct them or what you have done to correct them is what the response will need to be. And with that, I used my full hour, including the minute that Shane borrowed. So we'll take any questions that are there. Otherwise, thank you again for your participation.
Thank you, Tom. You had two questions, and one of them is, where is the final effluent on a 3-cell lagoon? You talked about DO samples at the weir. I'm talking more about TSS, pH, CBOD, stuff like that. The guy took his at the primary cell.
Okay, so your effluent sample would be somewhere right before it leaves the plant, whether that be at your effluent weir or if you have some effluent structure. Your effluent samples would be right before your discharge to the stream. So it's facility specific on exact location, but somewhere in that realm of effluent structure, final effluent weir, or something like that. Your influent sample would be on the front end of the plant.
Okay, and the other one was about a weir plate, and I dropped, when I got kicked out, I lost the question, but it was about a weir plate downstream from an ultrasonic flow meter and the distance that's allowable. I hope.
That sounds like a reasonable question.
John, if that's not right. Okay, the question is, how much can a weir plate downstream of an ultrasonic recorder affect recorded flows?
I would say your weir plate downstream is probably intended to be there so it backs up and you're measuring how much flow is actually going through or over the weir.
That would be my thought. It would be there to maintain a base level.
Yeah, if it's measuring flow through a flume and then you have a downstream weir, that seems like it may be problematic. If it's backing water up into the flume. But if you don't have a flume, then it is measuring the level of what's going over the weir.
John, if that didn't get your question, reach out to Tom. His number's on the screen. Or reach out to your specific field office. and they can help you with that questions about the specific situation. Those were the two. So thank you, Tom, for your presentation and your time today.
Thank you.
So I'd like to thank everyone for joining us. Again, if you have multiple people at your location listening in or watching this, please send us an email with who all is present so we know, so they all get CU credit. If you logged in today with a phone number rather than your name and you have not yet sent us an email matching your name with your phone number, please do that so you get credit for your CUs. As I mentioned earlier, this is being recorded and will be on the ISG YouTube channel, and that link will be in the confirmation email that you will get. The confirmation emails will be out by the end of the week, and what they will include is your CU credit. So for those of you who have been to other classes, you know, usually you get to keep the pink sheet. Well, this email is the equivalent of your pink sheet. So print it out, save it for your records, and that's your verification that you attended today and you earn the CUs. Again, thank you for attending. We plan to do these types of classes regularly. One of the things on that confirmation email will be a survey. So if you have topics that you are interested in or would like us to include, or specific speakers, please include that and send that back to us. We understand that sitting here for 4 hours gets to be a long time, and so we want to make sure we have topics that are of interest to you. That, I think, concludes everything for today. So again, thank you so much for the work you're doing. Have a great rest of your week and be safe out there. Thank you. Bye.